From Launch Complex 39 at the Kennedy Space Center in Florida, this is Shuttle Launch Control at T-minus 3 hours and holding. We have approximately 1 hour and 45 seconds remaining in this planned built-in hold, and we're now in the final 5 hours of the countdown for the launch of the last flight of the Space Shuttle program and Space Shuttle Atlantis on STS-135. The countdown is being controlled from Fire Room 4 at the Launch Control Center, and we're on schedule for a liftoff targeted for 11:26 a.m. This is the 135th launch of the Space Shuttle program, the 33rd launch of Space Shuttle Atlantis, its 12th to the International Space Station, and overall the 37th flight to the International Space Station by the Space Shuttle. This is currently planned as a 12-day mission that would have the landing at Kennedy Space Center occurring on July 20th. We're going to look now at some video of the rotating service structure, the gantry being pulled back from around Space Shuttle Atlantis yesterday afternoon. That occurred at 2:38 p.m. in conditions not unlike what we have at the moment. It was cloudy with some showers. And altogether it took about a half an hour to move the rotating service structure back into the fully parked position. The rotating service structure is the gantry that surrounds the Space Shuttle when it's on the launch pad. It provides access to the Space Shuttle and particularly to the payload bay so that the payload can be installed into the orbiter. And as well, it is also the weather protection for the shuttle while it's on the launch pad. The rotating service structure is 130 feet in height and rotates a third of a turn away from the shuttle before launch. Once the payloads are in the payload change-out room with a rotating service structure, they can be installed into the orbiter with a telescoping device called the Payload Ground Handling Mechanism. This also has 5 levels of access platforms that extend inside the payload bay of the shuttle to provide working access to the payloads. And the shuttle, as we see it there, weighs about 4,500,000 pounds. And once the orbiter is on its own and comes back for a landing, it'll weigh only about 6% of what it weighed at launch. We're now at T-minus 3 hours in holding with 57 minutes remaining in this built-in hold. This is Shuttle Launch Control. This is Shuttle Launch Control, T-minus 3 hours and holding with 54 minutes, 45 seconds remaining in this planned built-in hold. We're going to look now at some video of some of the activities that were underway to prepare Space Shuttle Atlantis for its launch today, going all the way back to the beginning of the flow when our first flight hardware began to arrive. These are the solid rocket boosters. They arrive by train customarily, making a long cross-country trip all the way from Wasatch in Utah, coming across the country on Union Pacific, Kansas City Southern, CSX, and Florida East Coast Railway. The barge brings in the external tank. This was on July the 14th of 2010. The solid rocket boosters had arrived just ahead of that in May of 2010. Once the tank is in the turn basin, it is offloaded from the barge and towed to the vehicle assembly building, where inside it will undergo some brief initial checkout before it's rotated to vertical and put into a test cell. And then it is later, after the solid rocket boosters have been stacked on the mobile launcher platform, it is lowered into position between the two solid rocket boosters. Solid rocket boosters are built up first, then the external tank is lowered between the two of them, and then the orbiter will join them later. Here is the main engine installation. Customary 3 engines are installed and then tested. This is the landing gear test. This was on January the 25th, 2011. One of the numerous activities that go on in the processing to prepare Atlantis for launch. These are the many thermal protection system tiles. That was the elevon being raised into position. This is some of the tile work. One of our tile engineers from United Space Alliance. We have a combination of high temperature tiles on the underside and lower temperature tiles on the upside. This is the closing of the hatch between the payload bay and the orbiter's airlock and mid-deck area. Here the hatch is being cleaned as it's closed for flight. The payload remaining still to be installed. The KU band antenna is deployed in a test to assure that it will deploy properly. Before the payload bay doors are closed, the KU band antenna will be providing a lot of the video that we'll see during the mission. This is the power-up of the orbiter in the high bay, the orbiter processing facility, to some of the checkout activities, particularly the crew equipment interface test activities. And then Atlantis is ready to be backed out of the orbiter processing facility and takes about a 20-minute trip over to the vehicle assembly building transfer aisle. Opportunity for the crew who's worked on Atlantis to wish her well. And once in the vehicle assembly building, the lifting sling is attached and Atlantis is rotated to vertical so that it can be hoisted and mated to the external tank solid rocket booster stack. And once it's hoisted up, it will go across the transom. It's rotated slightly, clears the transom by about 8 inches, and then it's lowered. As we see right adjacent and next to the external tank, that sets us up for the rollout, which was on June the 1st of this year, heading out to Launch Pad 39A for the final flight of the Space Shuttle program. About a 6-hour trip at about a mile an hour on the way to the pad. And that's a live picture of Space Shuttle Atlantis now on Launch Pad 39A. And joining us here in the firing room is Angie Brewer. She is the flow director for Atlantis, OV-104 as it's known. And Angie, can you tell us a little bit what's been different about this flow compared to others?
Well, to start out with, this is our second last flow. 132 was supposed to be the last flow of Atlantis, or the last launch of Atlantis, but it started out as a launch on need. This mission, STS-135, was originally STS-335, and we were going to be a launch on need mission if STS-134 needed it. Earlier this year, we got approval to fly STS-135. So when we started the flow, we didn't know if we were going to fly, but we were processing like we were, and we were able to, get a flight, and we're happy to be here.
Well, one of the things that we did this time was a tanking test. We filled the external tank with propellants, much as it is today. But in what ways did that turn out to have benefited us for this flight?
Yeah, we did a tanking test, and that was as a result of the STS-133, ET-137, where they had a crack in the tank, and because our tank is similar in pedigree to that tank, we chose to do the modification and then perform a tanking test to verify that modification worked, and it did. And it turned out to be a blessing in disguise, because the main fuel valve on engine 3 had a leak, and we were able to find that, because it would have been a scrub on that day if that had been our launch day and we hadn't done the tanking test. But fortunately, we found that, and we were able to replace it. And today, when we did our tanking test, it's working just fine.
Well, once Atlantis comes back, what will happen to it, since this is its last flight?
Once it comes back, it'll do its down mission processing, get the payload off, and then get all of its commodities and hazardous commodities off the vehicle, and it'll be prepped for wherever it's going, or to the visitor center here at Atlantis.
Right, it's going to be the one that stays here at Kennedy. So, well, Angie, thank you very much, and best of luck today. And I'm sure that weather permitting, certainly Atlantis will certainly represent the agency well for the last flight of the Space Shuttle program.
Yeah, thank you, George.
Thank you very much. 45 minutes remaining in this built-in hold. We're at T-minus 3 hours in holding. This is Shuttle Launch Control. This is shuttle launch control. T-minus 3 hours in holding. Just under 44 minutes remaining in this built-in hold. And joining us now is Joe Delay. He is the STS 135 payload manager, and he has been busy for some time stocking Atlantis with all of the supplies and spare parts that the space station is going to need for the next year or so. Joe, first of all, tell us: is the understanding basically correct that this is a logistics flight? Is that what this is intended primarily to do for us?
George, you're absolutely correct. One of the main objectives of this flight was to get ISS supplied again for about a year. Cargo, supplies, personal items, spare parts, science experiments, and as you mentioned, we have the MPLM filled with all these supplies up to about 8,200 pounds, which is volume-wise the most we've ever brought up in the past. So this is a very important mission for all of us.
Well, Joe, we've got some video now of some of the activities we did to prepare the payload for the launch. So if we could go ahead and roll that tape, and Joe, if you could tell us what we're seeing.
You bet. Okay, so it looks like we're in the SSPF, and they're getting ready to install the RRM onto the external carrier. That is the remote refueling mission, and this is a very unique experiment for us. It's kind of a first of its kind, where they're going to be robotically checking out and experimenting how to refuel aircraft on orbit, and we'll be watching that very carefully for future missions. And then what you're seeing here is you're seeing the racks that are being stowed with cargo, and they're being lifted and installed into the module. So total, we have 16 racks, and each rack holds various amounts of weight. We actually did some modifications to some of the racks down here that increase its weight by 200 pounds. This picture is we are getting ready to take our external carrier, which has the refueling experiment down below, and there's an adapter plate on top, so we can bring back the filled S1 pump so we can take a look at that. And it's going into the canister so we can get ready to go to the payload. The LMC that you're seeing, the external carrier, weighs about 2,906 pounds, and then when the module's done, you'll see that being lifted in. That weighs 25,359 pounds total weight. And you can see it's very tight. Volume-wise, a lot of packing went into the module. And now we're getting the aft end cone secure, and then we'll be doing purges and leak checks, pressure checks in the module. And then here in a few minutes, we'll be lifting that and putting that also into the canister. Most of this work happened around the April-May time frame. The goal originally was to get the payloads out to the pad based on the original launch date of June 28th at L-12, because we wanted to keep the hatch open as late as possible so we can make sure we get all the assigned cargo into the MPLM. So we're lifting the MPLM. We'll do a weight and CG, and then that will be brought over to the canister. Really interested, going back to the robotic refueling mission, it's the future refueling and repair of on-orbit spacecraft. The robotic refueling mission will perform what we call representative tasks, George. We're going to be turning valves, opening up QDs, transferring simulated fuel. The objective here is to prove that we can do that in space and eventually have robotics go up and service and repair on-orbit spacecraft and satellites. So we're in the canister, and we're at the canister rotation facility, and that was around June 14th of this year, and we're going vertical, and then from there we'll go out to the pad 2 days later, which will begin on the 16th. Another payload that we have on here that I'd like to mention is the DoD PicoSat. It's a PicoSat Solar Cell 2. The second time we've flown this, it'll be on a sidewall in the orbiter. And DoD will be working that. And basically what that does, George, is it's going to allow them to perform different types of tracking demonstrations at various orbits in space. Well, that's a beautiful picture of getting the canister to the pad and then lifting the canister up into the payload changeout room so we can move the payloads into the PCR and open up the doors and then get ready to put the rotating service structure back over the orbiter so we can get the payloads into the shuttle. And while that's happening, we also have a lot of different science experiments flying on this mission in mid-decks. This is probably the busiest launch that I've seen probably since my Space Lab days. We're bringing up 6 powered mid-decks, all science related, fluids research, materials research, medical research, plant research, and we're bringing up 5 passive experiments. All those have been loaded over the last day or two, and right now they're on board the spacecraft and everything's operating well. So you can see a picture of the external carrier, the LMC towards the bottom, and the MPM right on top of that. And once we get that installed, of course we have to check it out. We have various IVTs that we perform, and once everything looks good, we do our final closeouts, and eventually the orbit doors are closed for flight, and I think that's what we're seeing now. So eventually on this 12-day mission, on flight day 3, the orbiter will dock. On flight day 4, the MPLM you saw, the module, that will be attached to Node 2 on orbit. And then flight day 5, we'll take the robotic refueling experiment and we'll attach that to space station. And then the failed PM pump, the pump module, which is used to circulate the coolant on station. And we have 3 other spares up there, but we want to bring that one back, take a look at it, we want to understand it. And then that's flight day 5, and then flight day 12, we'll go ahead and deploy the DoD PicoSat satellites.
So we're not leaving this one on station. It needs to come back because it's got hardware to come back and other things. What all would be coming back with it?
So yes, the module is just temporarily stowed on Node 2 Nadir, and basically the idea is we want to bring back. There's spare parts that we don't need anymore. There's items that have to come back and be fixed, trash items. So yes, we'll be bringing back a variety of items that are not needed anymore on ISS. And then of course, as we mentioned on the external carrier, we'll be bringing back the pump module because it did fail. We don't know why it failed, and we need to take a look at that and learn from it.
Well, Joe, thank you very much. And I know the payload test team is also looking forward as much to launch today, but also to the activities after we get up there, because what's going up in the module and what's coming back is really the focus of this mission. So thank you very much for talking to us about the payload, and best of luck to your team throughout the remainder of the mission.
Well, I appreciate it. It was an honor. Thank you very much.
Yeah. And we have 35 minutes remaining in this built-in hold. We're at T-minus 3 hours in holding. This is Shuttle Launch Control. This is shuttle launch control, 3 hours and holding. 32 minutes 55 seconds remaining in this built-in hold. Joining us right now at the console here in Firing Room 4 is Master Sergeant Margaret Howard, weather officer with the U.S. Air Force 45th Weather Squadron. And Margaret, welcome. We know the crew is getting a weather briefing right now, so we're going to discuss that here very shortly so you can tell us what it is that they're hearing. But first of all, we have a new tool that is just making its first real use on a shuttle flight for STS 135. It's a brand new radar, and this has been undergoing construction and testing for almost 2 years now. Margaret, as we go along, maybe you can tell us some of what we're seeing as we look at the tape. But if we could go ahead and roll that. This was shortly after the groundbreaking on August the 8th, 2010.
Okay, here we can see that the contractors, they are putting the radome together. This tower is about 100 feet above the ground as opposed to the older one, which was only 60 feet. And with the radome on top of it, it puts it at about 130 feet. And you can see them there lifting it with the crane. Some of the advantages that this radar has over the old one is that this newer radar is dual polarization. This allows the radar to view precipitation particles both horizontally and vertically as opposed to just horizontally with the older radar. This can help identify the type, size, and number of precipitation particles, which greatly improves our warning accuracy. And you can see there also the new site is about 23 miles to the west of many of the launch pads on Kennedy Space Center. The reason it is here as opposed to on Patrick Air Force Base, where the older WSR-74 was located, was because one reason was the height. This one here, it would have intruded into the airfield safety corridor on Patrick Air Force Base. And another reason that it is here at the current site is because it has an unobstructed view to Cape Canaveral Air Force Station and Kennedy Space Center. On Patrick Air Force Base, the older radar had to transmit across many large buildings in Cocoa Beach to view the Cape and Kennedy Space Center, which greatly increased ground clutter. And there you can see the VAB. So there's a clear line of sight there from the radar to Kennedy Space Center, which greatly helps us a lot. And here we have Todd McNamara. He's our radar launch weather officer, and he is actually manning the radar as we speak.
Right here, we got the center line actually over Cape Canaveral while the radar.
There you can see some radar, some shower thunderstorm activity moving over the Cape and Kennedy Space Center. And actually, to his right there, that's Staff Sergeant David Van Squake, and he's actually at one of our TAL sites overseas supporting the launch mission.
Well, right now the crew is getting a weather briefing, and I wonder if you could go into that for us. Tell us what the forecast is today, what the outlook is, what do we see coming up over the next few hours, particularly when we get to launch time.
Okay, well, there's a tropical wave in the eastern Caribbean, which has been slowly pushing towards the north. For today, we're looking for almost the same weather conditions as yesterday, mainly rain showers and some isolated embedded thunderstorms. We still have a 30% chance of favorable weather for the launch. However, as the days progress, our chances do get better because the system pushes toward the north, and which makes it much more drier than it is currently. Our weather conditions at all three TAL sites are good to go, and also the abort sites at Edward and Northrop Strip is also good. So mainly we're just concerned with the weather here at Kennedy Space Center.
What probability is Kathy Winters currently putting on our forecast?
Yes, currently the probability is 70% no-go, which is
Okay.
30% favorable.
All right. Well, if we go into tomorrow, what does Saturday look like, and what does Sunday look like?
On Saturday, our chances are 40% favorable, and on Sunday, it's 50% favorable. So we're still looking for the same almost
Yes.
weather conditions.
All right, but at least the trend is in the right direction.
That's correct,
So
yes.
we live in hope.
Yes,
so,
we do.
All right. Well, thank you very much, Master Sergeant Howard, for telling us about the new radar and bringing us up to date on the forecast. And I know the crew is just finishing up their weather briefing and getting ready to go suit up. So thank you very much.
Thank you very much for having me.
We're at T-minus 3 hours in holding, and we're at 27 minutes now remaining in this built-in hold. This is Shuttle Launch Control. This is Shuttle Launch Control, T-minus 3 hours and holding. Here's our commander, Chris Ferguson. He's in the suit-up room. He's having a fit check of his helmet. He's our commander on this flight, and going over to pilot Doug Hurley. This is his second trip into space. He completed his first space flight on STS-127, and he's logged more than 376 hours in space. And here is Mission Specialist number 1, Sandy Magnus. This is her third space flight. She spent more than 4 months in space aboard the International Space Station. She flew on STS-112, logged 11 days in space, and then 4.5 months after being on board the space station as a member of the Expedition 18 crew. This is Rex Walheim. He's our mission specialist number 2. He's making his third space flight. He's spent more than 24 days in space on STS-110 and STS-122, and he's had 5 spacewalks totaling more than 36 hours. And he's served very effectively as the chief of the EVA branch. So the crew now is finishing their suit-up activities, and they are scheduled to leave for the launch pad in just about 25 minutes. Shuttle countdown is continuing to go very well. There's nothing amiss there at all. And as the weather is only the only concern, main thing will be continue to be the low cloudiness, particularly at the shuttle landing facility, should we have a need for the crew to turn around and come back with the shuttle for a return to launch site, and any precipitation. And we have now exactly 20 minutes remaining in this hold at T-minus 3 hours. This is Shuttle Launch Control. This is Shuttle Launch Control, T-minus 3 hours and holding. We've just had a weather update, which was passed to Kathy Winters, our shuttle weather officer, on the sea conditions offshore for the solid rocket booster recovery after launch today. And the ships are reporting that the seas are 4 to 6 feet. The sea temperature is 83 degrees in the water. Air temperature is 80 degrees. The winds are from the south at 20 knots, occasionally gusts to 24. Excellent visibility, at least 10 miles. And it is overcast, though, just as it is here. And Mike Leinbach, our launch director, has just asked for another update on the weather. The astronauts touched down at the shuttle landing facility at KSC, arriving from Houston on Monday, the 4th of July at 2:31 p.m. Since that time, Commander Chris Ferguson and pilot Doug Hurley have been honing their landing skills in the shuttle training aircraft. The astronauts have all done a final inspection of Space Shuttle Atlantis, had a fit check of their launch and entry suits, received a briefing on the status of Space Shuttle Atlantis and also the payloads. They've been following the weather forecast very closely since they've been here, knowing that marginal weather was moving in. And they've had their final medical exams and did a final review of their flight plan and then packed their flight data files and their personal effects, and they were sent out to the pad to be placed aboard the middeck of Atlantis. Today the crew was awakened at 4:30 a.m. Had a brief checkout by the flight surgeon before having breakfast at 5:45. And as we've heard, they've had their weather briefing. The walkout from the astronaut quarters is scheduled for 7:36 a.m. in about 20 minutes from now. And they're scheduled to begin boarding Atlantis at 8:06, and then the access hatch will be closed and sealed at 9:21 a.m. The ice inspection team, the final inspection team, has completed walking down the entire length of the fixed service structure, and they're just about now to go down to the pad surface and they'll do some final inspections around the mobile launcher platform area of the aft skirt, some activity to do there, and then they'll leave the pad. And they'll come back here to the Launch Control Center and report to our shuttle launch director, Mike Leinbach, and the engineering community about what they found during their walk down. The closeout crew is in the White Room now, and they are ready for the astronauts to arrive. Members of the closeout crew are in the white coveralls, and they'll be assisting the astronauts with their helmets and other equipment as they enter the orbiter. White Room is at the 195-foot level of the fixed service structure. The White Room's on the end of the orbiter access arm. There are 6 people altogether who make up the closeout crew. These include a pad leader, a support astronaut, a suit technician, a quality control engineer, and 2 orbiter mechanical technicians. And the final inspection team has now left the pad. They're en route back to the Launch Control Center. Most of the communications channels are really quite quiet right now. There are no significant issues in work for the engineering team to discuss, so they'll be waiting to hear what the final inspection team has to report. So other than weather, we continue to have a very smooth countdown going. And we have only 10 minutes now remaining in this hold at T-minus 3 hours. This is Shuttle Launch Control. This is Shuttle Launch Control, T-minus 3 hours and holding, 6 minutes 45 seconds remaining in this built-in hold. The final inspection team is now back at the Launch Control Center. Shuttle Weather Officer Kathy Winters is briefing Mike Leinbach once again, but from the briefing, what we heard being given to the flight crew, it doesn't sound like very much has changed. We're going to have astronaut Rick Sturko a little bit later on flying weather reconnaissance. A little bit before 9 o'clock, he's scheduled to take off in a T-38 jet to fly for an hour to do some of the initial weather reconnaissance. And based on what we've seen from radar and satellite, he's already been given some direction on where they'd like him to go out and reconnoiter. And then a little after 10 a.m., he'll take off in the shuttle training aircraft to further assess the current weather, as well as the weather's direct effect on the handling characteristics of the orbiter in the event of return to launch site. He'll be shooting approaches to the runway at the shuttle landing facility and judging the visibility and the wind conditions and its effect that it would have on the shuttle. And he'll be passing his observations to John Casper, the weather coordinator here in Fire Room 4, and to Lee Archambault, the weather Capcom at Mission Control in Houston. And the forecasters at the Spaceflight Meteorology Group in Houston, part of the National Weather Service, are going to be listening very closely to what he has to say and providing any updates to those forecasts, either for here at Kennedy for a return to launch site if that's necessary, and for the overseas landing sites in Spain and France. Right now, those sites all look good. All of the standard weather observations and forecasting normally performed before launch are being done today. The final phase began yesterday with a series of balloon releases. In the last 24 hours, about 24 weather balloons of all different types were released. And today we have 9 Raywinson balloons. Those are instrumented balloons to collect data on temperature, humidity, wind speed and direction, and barometric pressure up to about 100,000 feet. 6 gem spheres are being released. These provide very highly accurate data on the wind speed and direction up to about 60,000 feet. This data from the gem spheres is reduced, and late in the countdown, the flight dynamics officer will select the proper computer program that will allow the space shuttle's onboard computers to respond properly to the wind conditions that the gem spheres have observed as the shuttle Atlantis climbs through the lower atmosphere. Three and a half minutes remaining in its built-in hold. This is shuttle launch control. This is shuttle launch control. About 10 minutes remaining in this built-in hold. Coming out in 5, 4, 3, 2, 1. T-minus 3 minutes and counting, or 3 hours and counting. And right now the primary Ascent guidance data is now being transferred into the backup flight systems on board Atlantis. These are the flight profiles called iLoads. This is part of the Ascent profile that we talked about, where they'll be updated with the weather coming in from the Gensphere weather balloons. Flight crew will be leaving the astronaut quarters in about 5 minutes. As we saw in the suit-up room, there are 4 astronauts on this last flight who will shortly be en route to the launch pad. They'll be rendezvousing with Atlantis with the International Space Station on Sunday. Atlantis will be delivering the Raffaello multi-purpose logistics module, which is filled with supplies and spare parts to sustain space station operations when the space shuttle is retired after the current mission. There is one planned EVA, or spacewalk, on STS-135 outside the International Space Station to do as Joe July told us, to remove and replace a failed ammonia pump module used for thermal control, and to install onto the space station a technology development payload for robotic refueling. And the rest will all be devoted to offloading Raffaello with all of the supplies, spare parts needed for the station for much of the next year, and then bringing back a lot of things on the space station that are no longer needed. And here they come. Crew going down the elevator, where they'll be greeted by employees from Kennedy Space Center and members of the news media. This is the same elevator that's been used by the astronauts ever since Apollo. And there they go, escorted by NASA security. Also be a helicopter flying overhead. It's about a 20-minute ride out to launch pad 39A. About 10 miles altogether for the drive. We see the NASA headquarters building in the foreground and the Launch Complex 37 in the background where Delta IV is launched. Here we see the crew go by. And NASA Test Director Jeremy Graeber has advised NASA security that the Astrovan should be cleared through the roadblock to get to the launch pad just after they pass the Launch Control Center. NASA Test Director Jeremy Graeber now is polling the primary systems here in the firing room to assure that there is nothing amiss before we send the astronaut van out to have the astronauts begin boarding. That's a customary thing to make sure we have no launch commit criteria violations before we put the crew on board and they begin to board. And there are not. Range reports they are go at this time other than weather. And we're now at T-minus 2 hours, 50 minutes, and counting. This is Shuttle Launch Control. This is Shuttle Launch Control, T-minus 2 hours, 48 minutes and counting. Spatial Launch Director Mike Leinbach has just completed having a discussion with Houston Flight, the Spaceflight Meteorology Group, the 45th Weather Squadron, and some members of the mission management team. He, with the weather uncertainty, wanted to be sure we had a consensus that the right thing to do was to continue with the countdown and put the crew on board. And what he told the launch team was that we do have a shot at this today. So while it's not ideal, there is a chance for a launch, and the direction is to press on. So we'll be following the crew. They're letting off Rick Sturko so that he can go out to the shuttle landing facility and begin flying a T-38 to do some weather reconnaissance. And he'll later be on the shuttle training aircraft. And then they'll probably stop in front of the Launch Control Center to drop off some senior management and then head on out to the pad. At T-minus 2 hours, 46 minutes, 34 seconds and counting, this is Shuttle Launch Control. This is Shuttle Launch Control, T-minus 2 hours, 38 minutes, 26 seconds and counting. The Astrovan is now on the pad surface. The crew will be disembarking, and in just about 5 minutes they'll be headed up to the White Room to begin boarding. Our commander, as is customary, will be first aboard. Crew is doing what many of the crews like to do before they go up and board. They like 5 minutes or so to go up on the pad and take a look at Atlantis, pose for some pictures in front of the shuttle before they board. And then head over for the elevator. On the pad surface, they'll be going up to the 195-foot level of the fixed service structure. And we'll see the crew coming off the elevator here in just a moment. Commander Chris Ferguson and pilot Doug Hurley will enter the White Room shortly. Our mission specialists, Sandy Magnus and Rex Walheim, will probably wait outside a little bit and take the time to look around, enjoy the view from up there while the commander and pilot board. Very pleasant weather at the pad today. The temperature is about 82. Little humid, but other than that, it's not raining and the sun is starting to peek out. This is Shuttle Launch Control, T-minus 2 hours, 31 minutes, 5 seconds, and counting. The flight crew is now in the White Room of the Orbiter Access Arm. Members of the closeout crew are in the white coveralls, and the astronauts, of course, are in the orange pressure suits. The closeout crew will be assisting the astronauts with their helmets and other equipment as they enter the orbiter. And the closeout crew is scheduled to seal the orbiter access hatch at 6:56 a.m., but this can be done up to an hour later if that's really necessary. Right now, Chris Ferguson is being assisted with his launch and entry suit. He's our STS-135 mission commander. He's making his third space shuttle flight. He's logged more than 28 days in space, and he served as the spacecraft communicator, or the Capcom, on 4 space shuttle missions. He was the pilot on STS-115 and the commander on SAS-126. So during those 2 missions. He's logged more than 28 days in space, and he's also previously held the position as the Deputy Chief of the Astronaut Office. Joining us right now here in the firing room is Jim Kelly. Astronaut Jim Kelly is from Burlington, Iowa. He received his Bachelor of Science degree in Astronautical Engineering from the U.S. Air Force Academy and a Master of Science degree in Aerospace Engineering from the University of Alabama. He graduated from the U.S. Air Force Test Pilot School at Edwards Air Force Base in 1984. He was selected by NASA to become a NASA astronaut in 1996, and he was pilot on STS 102 in 2001 and STS 14 in 2005. He's logged more than 641 hours in space, and he's currently chief of the Capcom branch at Mission Control at the Johnson Space Center in Houston. So, Jim, welcome. It's very good to have you here today and to be able to talk us through some of the activities as the crew gets on board. Tell us a little bit what the crew has been doing besides the obvious things that they customarily do when they get up in the morning. What's been their activity like this morning so far?
Well, it's great to be with you here, George. Yeah, they've been basically getting ready for the mission this morning. They're towards the end of their day. They've been up for quite a while before they get to this point. And a little bit of a leisurely morning, relax a little bit, but then all business over the last several hours as they get their final briefings on weather, any changes in flight plans or anything like that. They sit down and talk about and eat a little bit of something before they go fly into space and then get ready to go. And all dressed up now. And Chris Ferguson, as we can see in the White Room, is just getting ready to go on board.
Now, you mentioned they're sort of at the end of their day. So once they reach orbit, what are the things that they'll be doing since this is kind of at the end of the crew day? How does all that work? How do you phase that?
The crew day is phased based on when they're going to rendezvous with the International Space Station. That's why the first day is kind of a short one on orbit. They'll actually get up there and open the payload bay doors, establish complete orbit, and then they'll change the rocket ship into an orbiting vehicle. They'll make sure that everything's set up for the next day. They've got all their equipment set up, their computer systems set up. They'll be just essentially preparing for the second day, which is going to be very busy, especially with the crew of just 4 people. So they're going to be one of the busiest crews in memory, maybe the busiest because they've got less people than normal to do all the normal tasks that have to get done. So they're going to be busy getting all their suits off, getting everything stowed, getting everything pulled out that needs to be pulled out, and all ready to go for tomorrow.
And let's see, I think that's is that our pilot Doug Hurley there that's just being assisted into his equipment, I think. Is the order always the same? I know you always start with the commander, but is the pilot always next, or does sometimes they put somebody else on next?
Usually when you have a mid-deck crew, meaning people on the bottom side of the orbiter, you trade off. You have the commander going first, and then you have one of the downstairs folks going next, and then you go back and forth. The upstairs order is always the same. It's always commander first, then pilot, then mission specialist 1, then mission specialist 2, just because of the way the seats are arranged, and you have to have access to each different one. So the order we see today will be the order that you always see for the flight deck, but normally you have people that are down in the mid-deck, 1, 2, or 3 people that are interspersed amongst these. So it'll be a little bit strange because we only have 4. And I'll tell you just a little bit about the closeout crew here. The closeout crew has been in existence obviously since the beginning of the shuttle, and they're just an outstanding group of folks. They've been together for a long time. We might not even see him here for a little while, but Travis Thompson's the lead. He's number 1. They all have numbers on the back of their gear and on their hats and things like that. And number 1 is called the OVCC, Orbital Vehicle Closeout Chief. He's been the crew lead, has 28 years on this team. This is an incredibly experienced and dedicated team that gets the people on the orbiter, and Travis is in charge of the whole thing. And not only is he in charge of this one, but he's in charge of the whole closeout crew. We can see here Chris Ferguson getting put into his seat, and the folks that are helping him get into his seat there are the number 2. If you can see the number 2 on him is Randy Brezhnik. He's actually a Marine Corps colonel. He's one of our astronauts. You can see him in the one screen. And Randy is actually getting on there to help out with the communications checks and all those kind of things. But the guy running the operation is Drew Billingsley, who's number 3. And you can see him kind of climbing all over there. If you look in the view there, you can see Chris Ferguson right in front of us, and kind of behind to the right, kind of leaning over, is Randy Bresnik, number 2, and now disappeared from sight is Drew Billingsley. He's called the flight deck crew insertion technician, the one that gets him on the upstairs. Born in Santa Monica, California, and grew up in Huntington Beach. Served in the U.S. Army. He's been in this role for a long time. He was initial suit tech in STS 86 back in 1997. What they're doing as they go through here is, as Chris gets in the seat, there's probably about 9 different connections that need to be made, both to the vehicle itself as well as within his own gear there. And as you can see, we're pretty much, as astronauts, just hanging back and letting them do it. The best thing we can do is let these professionals do their job. So you can see Chris is just concentrating on getting his hands out of the way and making sure that Drew has access to what he's working over on the right there is his liquid cooling. You've got all the straps that have to come around. It's a 5-strap harness. You have to get the parachute, which is what you're seeing there. Randy has the close one, and Drew has the far one. You get the parachute straps that are waiting for you. The parachute's already in the seat when you get in. They put those over the side, and they connect those in. You'll see a real good shot of that right here. You'll see them connected into the straps that Chris is already into, that he came in with his chest strap and everything. So that gets connected there. And they're essentially doing all these connections to make sure he's nice and snug in there and all ready to go. So you talk about the 2 guys in there. Drew is this is be his 11th mission. I'm trying to remember Randy, and this is Randy's first one as the number 2. So this is the first time he's actually inside the vehicle doing this setup here. So I'm sure he's having a lot of fun.
And this looks like Doug Hurley.
Yes, it'd be Doug Hurley going in, Marine Colonel. He is flying as the pilot on this flight. This is his 2nd flight. Flew a few years ago on 127. And he's being helped there. You can see the guys out in the white room. They get everybody ready to go. Number 4 there is Renee Arians. He's another longtime member. And by the way, all the guys that we've talked about so far are USA employees, other than Randy Bresnik, of course, who's the astronaut. But Renee has been with the United Space Alliance for a long time. 27 years in the space program. He's been for 40 launches. And he's just doing a great job for us. He's been the OVCC. He's actually had Travis Thompson's job. Travis is number 1. There's only about 3 or 4 people that are qualified to do that job at any one time, and Renee is another one. But in this flight, he's actually filling the number 4 role, and so he does a great job with it. He's going to be the hatch technician when they close the hatch and take care of all that stuff.
I mentioned Randy Bresnik. He's the ASP, right? Astronaut Support
Yep, it's called
Person.
Astronaut Support Person, yeah.
When does he get on board? He gets on fairly early, doesn't he?
He does. He comes out and gets everything prepared inside the crew cockpit before the crew gets out there and make sure that all their gear is in place. There's a lot of things they don't bring with them. They don't carry out with them that we take out for them. And I did this job quite a while ago, and there's a lot of things you take out there, get ready. You essentially triple check the cockpit to make sure everything's in place.
That's removed, and I was just curious if you had a test location in mind for that.
So he's like the first one that gets in the vehicle out there, as well as the number 3 to try to get things ready. So he's out there before just to, like I say, triple check, make sure everything's good to go.
What have the crew's activities been like since they got here in the last couple of days?
There's a lot of briefings when they get in town, weather, technical stuff that's going on with the shuttle, making sure everything's okay, which so far everything's going well. You can see the thumbs up there from Chris as he's getting strapped in. And hopefully what we try to get him is a lot of rest and relaxation time. Last chance to see their spouses. They can see their kids from a distance because they're in quarantine for the last week. So kind of a last chance to see the ones closest to them and get some time to relax. And we really beat crews up sometimes in training before they get to flight. And we try to get them down here to the Cape and essentially give them a few days where they don't have much to do so that they can relax, get a little bit extra sleep. We allow them to sleep a little bit extra. And also there's the time shift. If there's any remaining shift that they have to do to get to the correct work day for the space station and the shuttle when they're connected, they do that. So they've been doing a little bit of sleep shifting as well.
So when did they have to start sleep shifting for today?
It depends. We normally start our sleep shifts about 7 days prior, but these guys don't have a huge sleep shift. They'll be going to bed tonight. I can't remember the exact time, but it's around like 8 o'clock tonight, so it's not a big shift for these guys. It's a huge deal if you happen to be one of those flights that your day is exactly opposite, that you're getting up and going to work in the middle of the night and sleeping all day. So for this crew, it hasn't been too bad. They only had a couple hours to sleep shift, so it hasn't been a big deal. But in general, we'll start at about 7 days ahead of time while they're actually still at Johnson Space Center.
Well, I guess it's good they have a little bit of time to launch into space more relaxed, because when they're here for the countdown dress rehearsal, the TCDT, it seems like every minute is filled with things that they have to do.
Absolutely, and there's a reason we do that. For the Terminal Countdown Demonstration Test, TCDT, when they come out, we actually have, through the years, taken many things off of the launch flow and moved them into that flow, so they didn't have to do so many things before launch. It used to be that launch was as packed as that, and we just learned that, especially with post-Columbia, the crews have so much to do on flight day 1 and flight day 2 with the inspections and everything else that it's just critical that we send them up there relaxed and with a little bit extra sleep. So we've really tried to scrub the launch timeline to take out anything that's unnecessary. So what we're left with is practice STA flights, shuttle training aircraft flights for the pilot and commander, some briefings that they have to do. The crew will normally go out and check out all their computer lines that are set up. It's called the pre-wiring, that they set up all their computers and cameras and things like that. They go out and check that. But other than that, we try to give them free time.
Okay, it's on the F1 right front with the empty NR2 bag. We copy.
You can see Drew there working with Chris Fergie's communication gear. That's the white line that's coming down. It's actually from the back of the helmet that connects into the system, but that's the line that communication comes through. So you see that wraps around a couple times. And the black piece of gear we call the hot dog there, that's the quick disconnect. Everything that he's being strapped into the shuttle with has a quick disconnect, so they can just pull things instead of having to tightly undo things. Everything just has a quick pull that they can take apart in case they would have to get out. If there's some kind of emergency at the pad and instead of launching they're going to have to get out, there's a bunch of quick disconnects you pull, so they can just, for Chris, he would roll to his right, drop down on the MS2 seat, which Drew, or not Drew, but Randy Brezhnik is kind of on over there on the left. He would drop down on the seat down there and then get out of the vehicle. So that's part of the reason why it takes so long, is because everything's an intricate thing. You don't want anything to be tangled up. You don't want anything that can slow the crew member down if they need to get out of the vehicle. So,
Well, if I can fast forward 12 days after the shuttle lands, who helps them get out? Do they do this themselves, or does somebody help them get out of their seats, or how does that work?
when they land, we actually have folks that will go in and help them out if they need it. But most of the time, by the time you get the hatch open, because you have to do all the external checks, make sure the vehicle's safe, we're not leaking any hazardous gases or things like that. By the time they've done everything and get in the vehicle, usually the guys are unstrapped and pretty much ready to come out on their own. They've already got their helmets off, they've got their gloves off. And a lot of times, like the guys in the front seat will take all those things off. They'll hand them back to the mission specialist behind them. They'll stack them all on the flight deck kind of right above the ladder. And when the technicians get in at the end of the flight, they'll come up and take those things out. And actually, usually the first person in, I don't know if it'll be Randy on this flight, but it'll be another astronaut support person that comes in and starts clearing out all that gear. And then, of course, there's doctors available and all that kind of stuff. But usually the crews get themselves out, they get themselves unstrapped, and they don't need any help. People would seem to think, too, this is a pretty involved process. Usually takes about 50 minutes from the time the first person goes in the door to the time the last person's strapped in. And you'd think with 4 people rather than 7 it would take less time, but it really doesn't, because the flight deck drives the process. You've got 4 people. It's much more cramped upstairs. And the mid-deck is actually done in less time than the flight deck does, and they're concurrent. So it's a little bit odd. You'd think, okay, there's only 4 people. It's going to take, 25, 30 minutes because there's less people. But really it takes the same amount of time, because this is the timeline, the flight deck, and how long it takes to get those 4 folks strapped in is what drives the time.
Now, having all 4 crew members on the flight deck, did that allow any extra room for more things to go into the mid-deck, since we're trying to do so much resupply on this mission, or not?
I can't tell you specifically, but there are hard points down there, and if you have less seats, you do have some capability to put more gear down there. But it's not a huge amount of extra gear. You can't add extra lockers, for instance. The lockers are set, and they can't be changed, so you can't add extra lockers down there, so it's not a huge change. You can see the white one there. You can see Travis Thompson, number 1, over on the right. You can see number 5, which is Chris Minert. In this interesting flight, we talked about the number 1 being such a critical position. We actually have 3 number 1s on this closeout crew. We have Travis, who is number 1, Renee, who's working number 4, and then Chris Minert here is number 5. He's also a hatch technician who grew up in California as well. He's been working for a long time, worked the SR-71s and U-2s, and came out here. He's been working on the closeout crew since about 1990. And he actually won a Silver Snoopy Award pretty recently, back in 2010. So Chris is another person that's capable and qualified to be a number 1, but today he's working as number 5.
And this is Sandy Magnus. She's our mission specialist number 1. So when she gets in, I think she's going to be on the flight deck in the aft right seat.
That's correct. We've got a good view of it now.
They are complete,
Doug has gotten in from the middeck, and you kind of have to go in through the middeck through the hatch, and in the middeck you kind of take a right, about a 90-degree right. You have to go through the ladder access, which normally when you're vertical you'd be climbing the ladder. In this case you're going right, and then you actually crawl on the aft panels, and you can see that Randy's actually standing on the aft panels there as he gets folks ready to get in the vehicle. So we've got things down there that protect the aft panels, a certain place where you can stand. Like you notice, for instance, Randy's not standing on the switches. We can't stand there. But it's kind of intricate. You have to weave your way around, and so you come in the hatch, you turn to your right for about 90 degrees, go about 5 feet, you drop down to the aft panels, aft lower panels of the flight deck, and then you climb up on the Mission Specialist 2 seat, and then you have to get yourself up in the pilot or commander seat. So these are the hardest 2 seats to get into, and it's kind of a monkey bar thing. There's a grip up there that they grab with their hands, and then they put their feet up there, and oftentimes you'll see the technicians, either Drew or Randy, helping them get their feet up there and get all situated. And then the critical thing is getting yourself on the parachute correctly. You want to get yourself all the way down in the seat as far as to the seat pan as you can, because the shoulder straps of the parachute can be quite painful if you don't get those a little bit loose. So you got to make sure you're as far down in the seat pan as possible. So you see a lot of adjustments here where they're pushing on them and pulling on people and getting them in the right place. And it's kind of a manhandling task. Obviously with the suit weighs a lot. It usually weighs about 50 to 60 pounds. And so they're carrying a lot of extra weight, and it's bulky, and it's hard to get where you want to go. And that's why we have so much extra help in there for these guys. This job is almost impossible to do yourself on the ground. On orbit, it's pretty easy. You just have to set things up, and you're floating, so it's a lot easier. You can move around a lot more readily, and the bulkiness doesn't hurt you nearly as much when you're in zero G.
48, CMT and MT adjustment is complete. Ready for IMU platform positioning. Copy that.
Okay, can the astronaut, this is on the flight deck for some time before launch, is he at the ability to shift his position any or move around to get a little bit more comfortable, or is that
not a whole lot? You have just maybe an inch or two of play in each direction as you move around. You can see there's a certain equipment to make him more comfortable. You can see behind his head there's a headrest there, and those are actually by size. Each crew member picks what size they want that headrest to be, and it depends on how high they want their head up. If you didn't have that at all, you'd actually be holding your head up the entire 2 or 3 hours before launch, which would be incredibly painful. But they get to pick how big they want that headrest to be. Everybody has a lumbar support. It's hard to see here, but there's a little black tube down by Doug's right hip. It's a little black bladder that you can see in your hand, and he would take that and squeeze that up, and you can actually get lumbar support from that. You can reach down to the seat pan and pull yourself down a little bit, which is good. There's a monkey bar that's right above Drew's head. It's about directly in front of Doug. He's actually almost looking at it right now, where you can pick yourself up and move yourself around. The other thing that we do for comfort that's the absolute best thing we can do, and we'll see this a little bit later with Fergie, is once you get your helmet on and your gloves on and your suit is completely one piece, so it's all sealed, then you can pump air into your suit. And what that does is it gets all the wrinkles out of your suit. Because right now, the way Doug's sitting, when you lay down, obviously there's extra material. It all gets kind of lumpy, and you can get folds. And if you get a fold underneath you, that can be very uncomfortable. So we actually can pump pressure into the suits and overpressurize them so you kind of look a little bit like the Michelin Man. And that gets all those things out of the suit so that you're much more comfortable. If you don't do that, then you can be very, very uncomfortable. Once you've done that, though, things are usually pretty comfortable. So it's pretty critical to get in and get set, especially with your parachute straps. If you do that blow up of your suit and get all the wrinkles out of your suit, then once you do those two things, you can actually be pretty comfortable as far as laying on your back for 3 hours goes.
CNTC, can I get somebody on 162? Yes, sir. And CJLS, we're ready for 651. Yes, ma'am. Thank you.
Kind of see here once again, Drew is reaching around and making all the connections for Doug. He's just keeping his hands out of the way. Sometimes as an astronaut, the best thing you can do is nothing, and this is one of those times.
Thank you.
There are other little tricks these guys do as well. You can see that Doug right there on the right side of his, he's got a comm cap on, communication cap, which actually hooks around, and it's got the boom mics that come out you can see next to his mouth. And then that white cord that goes in next to it, that's the cord that actually connects into the helmet. So the comm cap connects into the helmet, and then the helmet connects into that white cord we saw earlier on Fergie that had the hot dog on it. And they tuck that back in the communication cap so it doesn't go flailing all over the place, because it's real easy to get that thing in between your connection where you put your helmet on. And it's critical to make sure that there's nothing on the seal of your helmet. And there's a lot of things hanging out, microphones and chin straps and that communication gear there, and your suit can get up in the way, and you've got a bladder inside your pressure suit which can get over there. So it's really critical when they put the helmet on to make sure that they've got a clean seal there to get that thing mated correctly so that the suit will work properly. So that's one of the reasons you've got that white communication line there tucked into the communication cap, the comm cap, so it doesn't fall all over the place.
Well, it's nice to see here in the firing room we have some sunshine coming through the windows, so hopefully that's a positive sign. How closely has the crew been watching the weather here for the last couple days?
In general, as crew, we don't watch the weather. It's a 50-50 shot. Either you go or you don't. It's not something you really want to worry about. There's a lot of other things we need to worry about, and weather's just not one of them. You hope for the best, and you trust the launch team to make the right call, and they always do. And you just get out there hoping that you'll go, and if you don't, you shut things down like you're supposed to, and you get ready to go another day. It's happened so often for so many folks. There are very few astronauts that have 3 or 4 flights, or even 2 flights that haven't had a delay of some kind or another, so it's something you get used to. You just leave that to the other professionals, not something you can control. You just strap in and hope you go.
OTC CBSE 212.
You can see here it's really good to have 2 people helping out. It's kind of a 2-person job. Randy's kind of the underneath man there. He's handing things up to Drew. Drew's kind of standing on the mission specialist 2 seat and reaching across Doug and making sure everything's connected. And so the 3 of them really work as a team together, helping each other out.
RSRT, OTC? Yeah, can we get new digital tapes for the range safety monitor station, rack 8234? Okay.
You can see Doug pulling down on the bottom of his seat like we talked about there. He's kind of pulling himself down into the seat, which is pretty critical. And Drew back there is kind of pulling on his shoulder straps to make sure that the shoulder straps are a little bit looser so he doesn't get that shoulder discomfort that you can get very easily if they're a bit too tight. This is a great shot from the very front coming down that we just had there, and we'll come back to it. But that shows you a little bit more of what the inside of the cockpit looks like. You can see Chris Fergie on the other side actually getting his gear in place. Once you're strapped in, you got your helmet on, everything like that, there's a bunch of checklists and your own personal gear that you take up with you that you want to get put in the right place. And you can actually see Chris hanging things in front of himself over there. And you kind of make your own little nest. Everybody has the way they do things, and there's Velcro all over the place. So you can put your checklist in the right place. And you always have a couple pencils hung up, a couple egg timers, we call them, because you want to write things down that the MCC or LCC calls to you before launch and then after launch. You want to make sure you've got a timer in case. We use timers for any number of things, but usually if any kind of problem happens, you're immediately hitting a timer because it's very important in many cases to have a timer going from the start of a problem to when you fix it. So there's a lot of things that you're doing there. So Chris is over there getting his nest all built while we finish Doug up on the right side.
And all those items are already on board when he gets on board?
They're all on board when he gets there, and they're either waiting for him on Velcro and he just moves them around, or once he's on, Randy will hand them to him. And Randy's got him sitting down there on the bottom, and he'll actually hand those things to him and make sure they're all ready to go. So in some cases, there will be things that they have in their pockets. That's usually not the case, but sometimes they'll have a thing or two in their pocket to carry up there with them that they put up. And they bring the last checklist out with them because they actually have a checklist when they have the pre-flight weather brief that happens right before they suit up. That's the last thing before they suit up. So those actually come out with Randy after the crew, because the crew's writing in those based on the weather briefing. And after they write in them, they hand them to Randy, and Randy brings them up to the pad, and he hands that to him. So it's kind of a handoff from the crew to Randy, and then Randy back to the crew. You can see there with the helmet going on, as I said, that seal is critically important, and it was very illustrative of why we have that comm cap, why we have that communication cord tugged into the comm cap there. You can see that Drew's working really hard here to get the bladder out of the way and make sure the helmet, when it goes on, clicks. It's got dogs, we call them, all the way around. You want to make sure it clicks down very well, and if it doesn't click down, you take it back off. Probably means there's a bladder in there or something like that. You can see he just took that communication wire out of his comm cap and got the one from inside the helmet. So that's the connection from the comm cap that Doug's wearing to the helmet, the white helmet. And then that other connection we saw in Fergie earlier is the one that goes from the helmet to the vehicle. So it's a white cord. You see those white cords, and those are all communication. And that's what Drew's going to do now. Same thing. He's going to take that hot dog, wrap it around twice, and then connect it to the communication system of the orbiter.
It's time to come home. How do they do all of this without help?
Like I said, when you're coming back home and you're in 0G, this is so much easier because you can float, you can grab things and all that. And usually the mission specialist number 2 will be helping everybody else get in. And then once that person's ready, so in this case Rex, on orbit will be helping the pilot and commander in and helping Sandy get in her seat and getting that all set. And then once everybody else is in, Rex will get help from Sandy because Sandy's sitting right next to him. So Sandy will be helping hand him things and stuff like that. You can actually do it all yourself. I did it on orbit all by myself. Got in a little bit early, to get situated and stuff. And if you set things up right before you get there, think ahead a little bit, you can actually do everything yourself, including get your helmet on, your gloves, and it's just so much easier in 0G. You can see in Drew's hand right there, he's got a checklist, and that's a personal checklist
Yeah,
of Doug's.
OTC.
And what Doug's doing with that there
OTC.
is that's his personal clipboard that you write things down on. You keep track of emergencies and things like that. You can actually see Drew taking that. It's got an elastic band
ma'am.
which goes around the left
As
thigh,
soon as we get
and you
the
can actually
crew
see him
in
hooking
and
that
you have
around
people
Doug now.
that are
So
available,
each crew
we'd
member,
like
things are pretty
you
standard when you
to,
get
see if you can
strapped
go
in.
down and
All
get
the
the hat.
straps are
I will
standard.
do that.
The 5-point
Thank you.
harness,
And we're,
the
after hatch
parachute,
closure,
the
correct?
liquid coolant, the communication gear, all that's the same for everybody. What's different are these things like that, and the crew briefs the closeout crew members, in this case Drew and Randy, tells them exactly what they want and how they want it, and they work together as a team, and it's a very tight choreography, and that's one of the things you do at the TCDT is they go through the choreography and make sure everything works, and there's always a debrief afterwards to say, okay, I want to do this a little bit differently, we've got something extra, we're going to change things up a little bit. So these guys work together as a very tight team.
Station Houston on 2 for Ron and ULS 7 pre-pack.
Did I understand you to say earlier that even though there's only 4 crew members, that because of the way the process works, it's not going to take any less time to get everybody on board? Is that what you were saying?
It's not going to take any
that
less
Doug?
time to get folks on
they
board.
need
That's
your
because
support on,
whenever you watch a
one-
strap in, the timing is all set by the flight deck, because
Say
you've got
again,
4 people instead of
They
3
need your support
downstairs,
on
and so
161.
much less room.
Copy that,
Like
thank you.
downstairs, there's so much room to get people in. It's easy to move around, much easier to do things. You can see how cramped it is up here. I mean, it's very hard not to bang your head on things and bang your hand on things. And of course, there's 400 plus switches that you could hit, none of which you want to. They're all right now. They're safed or they're covered, and that's one of the things you'll see Randy do later is he'll be taking the cover off the most critical switches because we make sure they've got covers on them when the crew goes in. There's plexiglass covers that cover panels. There's switch protectors that cover panels, and those will all get taken out by Randy. But you have to be very careful on the flight deck and be very deliberate about your motions so you don't hit any of these switches. You don't knock something at the wrong time. And so you'll see that, like Drew right now, has his head jammed all the way up against the front cockpit panel there. And he's got to watch his head as he does all of these things. But at the same time, you have to get the job done. So it's very difficult to do. And that's why the flight deck takes so much time. And really, the mid-deck happens during the flight deck. And so it's time that you don't – right now, we don't have anybody doing it, but we don't need them.
The way I read this table is I have this item 447.
Seems like a lot more activity when you're strapping 7 in because you're cutting back and forth between flight deck and mid-deck. There's a lot more going on, but it takes about the same amount of time.
Those items inside that CT bay once I find them. But when I look over at the pre-pack location for 447 Bravo, it's a different location than the bag and the covered angled stamp 447 Alpha.
Sure enough, I see what you're saying. Let us check.
Okay, and I also rebooted SSC 4. I think it's 4. And the same SSC.
You can see back in the white room here, you can see Sandy saying goodbye to everybody. Everybody gets pretty close like I talked. These guys are really proud of the job they do. We actually got a nice shot there of number 6 and number 7. Number 6 is the guy that's not USA. He's actually NASA quality. So USA has the contract to do all the operations there in the white room, make sure everything's done right. They're the guys getting all the equipment out of the vehicle. They're the ones taking care of the hatch. They're the ones taking care of all the crew equipment that has to go in. But NASA has their own representative out there. In this case, it's Jack Burrett. He's number 6 on your screen before. 25 years in the space program. He's done 15 launches, and his job is really to check everything else that's being done. He's got the checklist that he looks at, and he watches over and behind and goes after and makes sure that everything that the USA technicians do is absolutely perfect. And so he's the quality control, if you want to look at it that way, to make sure that everything's done right. So everything we do in the space program, whether it's on orbit or down here on the ground, it's not one person doing it. It's usually 2 or 3 or 4. You have somebody doing the work and somebody checking them, and sometimes a third person coming back and checking. And really on the closeout crew, you have 2 guys doing that. Travis Thompson is a true professional, is number 1. He's checking everything that everybody's doing as a USA guy. So he's checking out his whole USA team, making sure they're good to go. And then Jack, as the NASA guy, is checking everything as well. And then Randy, as he comes out, will be triple checking everything. So we've really got the OVCC number 1 Travis checking everything out. As a USA guy, you got the number 6, the NASA guy, checking all the quality of everything that's being done. And then you get the astronaut number 2 as he comes out.
Now, this is Rex Waldheim. He's mission specialist number 2, but he's also the flight engineer, correct? And what does that mean that a flight engineer does, distinguished from, say, what Sandy Magnus will do?
Okay. Yeah, this is Rex that we're seeing there, that he's getting put in his suit here, or in his harness. The flight engineer is, the way to think about that is he's the right-hand man of both the commander and the pilot. He actually sits in that center seat right between them, and he's backing both sides up on everything that happens, especially if there's any kind of emergency or off-nominal events. He's the guy that's handling that and letting them know what's happening. He's running a lot of timers. He's keeping track of other checklists and what's going on. He's kind of the commander usually has the bigger picture, but you want your mission specialist to kind of be, he's a little bit further back. He doesn't touch any switches. He's got like one switch that he touches, and that's only on landing. Everything else pretty much is handled by the forward guys, and so he's kind of the big picture guy to look at that. He keeps track of checklists, and he helps the guys out in the front. So he has to have as much knowledge as the pilot and commander do of all the systems, and it's kind of interesting. He almost has to know both. As well as the pilot and commander do, so it's a very difficult job, and they're worth their weight in gold.
Good morning.
Some of the communications checks now just getting underway, which we'll hear from time to time.
So the last guy we haven't talked about, while we're watching Doug finish up his strap in here, last guy we haven't talked about is number 7. That's Ray Cuevas. He's also a USA guy. He's actually the mid-deck crew insertion tech. So today he has nothing to do inside the vehicle because there's nobody on the mid-deck. However, if you noticed, and you can kind of see here, Rex is kind of done with the process. Outside the vehicle, when they get their harness on, we have a crew insertion tech like Drew, who's on the flight deck now, or Ray, for the mid-deck, that actually makes sure that everything's set on the outside. So Ray was making sure that the shoulder straps were on there. You want to make sure you pull the material out from underneath. And once again, shoulders are a really hard thing to make sure that you get them comfortable with all this gear on. And so they were pulling the material out to make sure that it's all completely, the neck straps are right underneath the neck, the shoulder straps are underneath the neck there, making sure everything's nice and comfortable for the crew before they go in. So normally, Drew would come out for each of his flight deck crew members, and he would check everybody before they came in. Since we have 2 insertion techs, and we're not putting anybody in the mid-deck, you can see there that Ray was actually doing that job. So Drew's actually staying in the cockpit, so this will shorten the time a touch. Drew is actually staying inside the cockpit to get everybody strapped in, and Ray is getting everybody in their harness the correct way on the outside. So the insertion suit techs, which are the number 3 and number 7, they're the ones that are totally in charge of making sure the suit's on properly, everything's connected, probably everything's good to go, and the crew member's comfortable.
Switch reconfigured for your Ascent checklist.
3-minute drying time on schedule. Question, do I have a lot water that droplet still hanging on the best stripper and leave it there?
We copied in the 3-minute waiting period.
Ray was born and raised in New York City. He's been working for a long time, EMU technician since 1983, transferred to Crew Escape after that. He became an entry suit technician in 1990. He's been a closeout crew since 1999. I've actually worked with Ray in this job, and Drew for that matter, and he's supported 17 flights, so Ray's done a lot of flights. Matter of fact, all these guys are high-experienced guys, so every single one of them that's out here. Kind of see Doug's already done his comm checks. You can see that he's got the helmet on, everything there, so he's all set to go. They should be working on Sandy now. Matter of fact, you can see, well, we'll go to that shot here in a second. We're showing Rex out in the white room, and you can see once again that Ray is working on the shoulder straps and everything there to make sure that everything looks comfortable. He's pulling that material out from underneath. And inside the vehicle, we've got Sandy just starting to get strapped in.
Hey, Christy, in item 447, even with the 2.0 CTV, like this EVA transfer bag insert assembly, the only way I can get that.
So Sandy's in the back on the right, and Rex Walheim is right in the center between the commander and the pilot. Is that his vantage point?
That is correct, yeah. The center seat, which is actually where Randy's standing right now, he's actually standing on the seat that Rex is going to go into. And what he's doing is he's actually throwing some switches for the pilot and commander, make sure they can reach them, make sure that they're in the correct configuration, because there's a few switches that need to be thrown, as well as checking the caution and warning system before they're done strapping things in. Meanwhile, you can see Drew, number 3, is actually kneeling on Rex's seat to help take care of Sandy. Sandy's in the seat, like you said, it's in the back right. from a flight deck perspective. She sits behind the pilot. She doesn't have much of a view of anything. She can kind of see crossways over to Fergie's displays, but she can't see really anything in front of her because Doug's sitting right in front of her. She does, however, to her right-hand side have a computer display that she can control and see the data on there. So if there's any data that needs to be looked at in the back two seats, it's actually Sandy that'll be looking at that because she's the only one that has access. So the mission specialist number one.
Switch reconfig is complete.
Copy that.
The mission specialist number one is not like the flight engineer, but they help out a lot too. They take a lot of notes. They keep track of things, and they can check backup check data on the screen, set timers, things like that. So they're kind of the overrun person. Anything that can't be handled by the rest of the crew, they pick up.
OTC, yeah, we're going to take a do not perform on the constant warning adjust. We'll leave it where it is.
Okay, leave it the way it is. Copy that. Thank you.
I would estimate, looking at the difference between 100 and 200, I would call
CMTC,
25.
take a not perform under the header. Copy.
See out in the white room, that's Chris Menard again, number 5. You got Travis, number 1, and they're just getting Rex in. So hopefully, if things go well today, this will be the last astronaut you'll see climbing into a vehicle to go fly in space on the shuttle.
644 through 647 are complete.
Copy that.
Okay, I will add it green label 660 and
Got that front view again. You can see that Drew is still working on Sandy over there, so they'll bring Rex in, and Rex will actually, that interdeck access that I talked about where the top of the ladder is when they come in and turn to the right, you'll see that Rex will actually pause in there. We can't quite see him in this camera, but he's just behind Fergie and below. He's actually right there ready to go, paused and waiting, because Drew needs to finish up getting the helmet on Sandy and taking care of her before he vacates Rex's seat, which he's kind of commandeered here for a little while. You actually, and you can see why, you actually could not get Sandy into her seat if Rex was in his, so that's why the order goes this way. The mission specialist number 2 seat takes a lot of abuse because Randy and Drew, as you've seen, are all over it. They're standing on it, kneeling on it, crouching on it. They have to be all over that seat to get the commander in, the pilot in, and the mission specialist number 1 in. So that seat takes quite a beating, but luckily it's built for that, and it was built with that in mind. Randy actually, at the top of the screen there, he's actually standing on the aft windows. So we have aft windows that go to the back of the payload bay that you can actually see to the back of the payload bay. When the payload bay doors are open, you can look outside. We actually have hard panels on top of those. They actually sit and they're anchored by the metal around the window, so not actually touching the window at all. But we put a lot of those kind of things in there, so there's places for Drew and Randy to step on and the crew to step on as they come in. That's one of the most critical parts of Randy's job is it's kind of like painting a room. You don't paint yourself in a corner. When Randy comes out, he's going to pull every bit of non-flight gear with him. And you'll watch when we get back to the white room later, there's 2 people actually taking inventory as it comes out. Every individual panel or a red flag that says remove before flight or any protective gear, all those switch guards we're talking about. There's covers that go over the rotational hand controllers, the flying controllers that the pilot and commander have. All those things come out of the cockpit. Randy pulls all those out as he leaves and essentially paints his way out until he gets to the hatch. And when he comes out, the last thing he'll do before he leaves the vehicle is he'll check with the USA techs and with Jack Burrett, the NASA quality, and he'll make sure that everything's out of the vehicle.
Now we hear the orbiter test conductor every now and then. How is the orbiter test conductor in the firing room at this point in time interacting with what's going on the flight deck?
Well, they're keeping track of, like we talked about before, there's some switch checks that they do on board. There's a caution and warning check that they do. So anytime a switch is being thrown on board, which there are several once the crew's strapped in, OTC is completely dialed into that. So it's kind of a choreography that's well thought out ahead of time. None of this is on the fly. None of this is something they're thinking of right then unless you get an off-normal situation. It's all done per checklist, and the crew is following their checklist. The OTC is following their checklist. NTD here down at Launch Control Center, the NASA test director, the launch director, and then all the folks at MCC are watching the same data, listening to the same thing. So everybody's watching this as they get ready to go. Everyone's on their checklist. We heard the Capcom from Mission Control, Butch Wilmore, talking a little bit earlier, doing the comm checks with the crew. So there's comm checks for all the different systems, and it's all the choreography has been honed over many, many years, decades at this point, been honed to the point where you can get this to a minimum, because we would like to spend the minimum amount of time out at the pad once the vehicle's fueled. So they've got this down to a very tight choreography to make sure that everything can get done. We can get everything done safely and get the crew off as quickly as we can. Plus, the faster you can do it, the less time you're laying on your back, which is a nice thing. There's a good shot back there of the panels that they were standing on. As Randy moves to the side, you can see his foot's right down there. There's yellow tape all over that panel back there. Anything that's coming out of the vehicle has yellow and black tape on it or red tape. It's very garish because you don't want to miss it. It's good. They've got these huge remove before flight red tags that oftentimes you see on airplanes, on covers on airplanes. They've got this little banner, red banner hanging down, and that's all so that it comes out. You notice the cord for the camera. The camera that we're seeing now is not a camera that goes on orbit. It's actually a camera we use just to show folks, like we are right now, what happens inside the vehicle. And Randy will pull that out when he goes. And if you look above Randy's head in the upper right-hand part of the picture there, you can see that yellow cable going across. It's just hanging there. It looks kind of not good because it's just swinging. Well, that doesn't actually go up with the crew. That's part of the whole camera gear. And so as Randy pulls the cameras out with him, which he's about to do there, it's looking like he's adjusting the camera. As those come out, all those wires come out. You can see one in this picture here behind Doug's head. You got kind of a yellow cord there. That yellow cord comes out. So anything that's in the vehicle that's coming out is yellow or red or yellow and black, so that Randy, when he leaves the vehicle, can make sure that he sees everything and pulls it out. Because the last thing in the world you want to do is leave something that's not supposed to be on flight up there, especially because once you go 0G, those things could start moving around and banging, and that's why we have such a tight system for 3 people checking to make sure everything's come off the vehicle.
So how's this camera that they'll take out different from the ones that are going to be on orbit?
We actually have, these are called lipstick cameras. We actually have a few of these that we fly on orbit. So they're flight-like, and they could be flown actually. They're the same as the flights, and the cables are the same as flight, except they're colored yellow, so that we know to pull them out. So that's a good thing. And there's a video camera. So most of the gear is the exact same gear you would use for flight, but anything that's going to launch has to be stowed and in padding and behind doors and closed and all strapped down. Obviously, this one's just out in the open like this.
So you'll take those out after you get up there.
Once they get up there, they'll pull all those out. As a matter of fact, a lot of the place where they're standing behind Sandy and Rex's seat, almost all the camera gear is in the lockers down there. And it's all lockers, and that's why they can walk all over that, because it's just locker doors. It's not switches or things like that. So most of the camera gear goes back there. So they'll spend a lot of time later on today, once they get on orbit, taking care of that.
Station Houston on Space to Ground 2 for Ron and covered angled stamp.
You can see both Doug and Fergie in the front are both completely set up with their gloves. They've got their helmets. They've already done that pressure check I was talking to you about, where they fill up the suit completely and get that all done. You can see Sandy back there is doing her final adjustment. She's getting her microphones, her booms. They come off the comm cap all set there. Randy's kind of going up above her now. Once Drew gets done, Drew's responsible for making sure all the connections are good. Once he's done, like I said, everything gets double-checked. Then Randy will come by after him. He'll check all those connections, and then he'll ask the astronaut. So he's talking to Sandy right now. He'll be asking her to check all her connections. You know, show me where your harness connection is. Show me where your bladder connections are for your lumbar support, the bladder for the lumbar support. Show me where your green apple is. The green apple is the emergency oxygen that they fly with. And so on their right hip, we've seen it a couple times with Doug, you can see a green apple there, as we call it. If you pull that out, then you get an emergency supply of oxygen that goes into your suit. So Randy is busy talking with Sandy and making sure she can feel all those connections are all set for her. She's all set, and he's doing that.
MS1, this is OTC. I got you loud and clear. How many? And I loud and clear as well.
Station mic on 2.
Good morning, Sandy.
Step 6 at 1.1.6.
Good morning.
Ready for step 10.
Super, and
That's step 10 and 1.603.
that's understood. While we are waiting for the valve to close,
Kind of see that first communication check for Sandy is done with the helmet open, just to check only the comm system now. We're
NTD, MS1, com check. MS1, this is NTD, and I have you loud and clear. Good morning, Sandy. And good morning, I have you loud and clear as well. Houston, MS1, com check.
MS1 Houston, we read you loud and clear, Sandy. Good morning.
010.
And good morning to everyone there in Houston. I have you loud and clear as well.
Juliet, also known as serial number 1066.
As I was saying, we do the first comm check with the visor open, so it's just to check the communication system. After that, we'll go ahead and close the visor and make sure the communications work with the visor down, that nothing gets upset by there. There's no comm cable that's stuck in the visor. or anything like that. So we do a comm check with NTD and then with Houston with the visor down. Sandy's currently right now pumping up her suit. There's actually suit controls that Randy makes sure that she can reach, and you can pump up your suit like we're talking about for the comfort. And once that's all done, then they can do whatever they want to do.
I can verify that 684. Copy.
You can see it's really tight quarters in there now. Randy's kind of working in between Sandy and Rex's head while Drew's still hanging over Rex and getting him all set. So it's very difficult. You'll see Randy has to go above Rex's head to get out of there. It's very difficult in tight quarters to be able to do that.
This is SK.
Yeah, based on your discussion.
For Fergie and Doug, they're both completely strapped in. They're doing well. They're actually talking with each other. You can kind of see making sure their checklists are all set. Pilot and Commander are a very close-knit team getting everything done with their mission specialist number 2. So they're making sure all their checklists are all set to go, all their gear's in the right place. Everything's all good to go for launch.
I copy.
Okay, we like your suggestion. You can use a half.
What's it like in the crew compartment once you get inside 9 minutes, particularly 5 minutes?
Well, really, once you get inside 9 minutes, you're just hoping everything's going well. You're hoping you get the go for launch, weather's all good, that there's no airspace incursions, which we've had a few times. You're looking to see what's going on, and really you're in your checklist at that point. You're watching all the systems come up. You're making sure everything's pressurizing correctly, and really you're the 50-second redundant check to everybody on the ground, both here at the Launch Control Center and Mission Control Center. They're looking at the same data you are. But obviously you're going to do it again because you're the crew that's on the vehicle. And so they're looking at all their gauges and going through their checklist. Inside 9 minutes, there's a lot of checklist items you have to do, including probably the most major one is at 5 minutes. The pilot will start up the auxiliary power units, the APUs. So there's a lot of stuff happening inside 9 minutes. There's comm checks going on, final briefings to make sure that if there's any changes to the winds or weather at KSC, if they have to come back and land here or anywhere else. You're going through your checklist. You've got all the displays for the different systems, and you're usually paging through those displays one at a time, just checking to make sure that everything's nominal and good to go, and making sure that it all looks good to you.
Lines removed, no leakage or drop noticed. I'm in step 10.5. Hardware disconnection completed.
Good. Hardware disconnection completed. You can press on.
Hoorah.
Got a great shot of Doug here over on the right. He's looking over pretty much directly at the camera. What he's actually looking at is he's got a checklist over there that he's taking a look at. And he's talking with Fergie right now on the intercom. So we can't hear the intercom, but that's what he's talking about. A lot of times when it comes time to go, Randy probably can't reach that camera because he'd be like crawling all over Sandy's head. So a lot of times the pilot will actually reach over and give that camera. He'll actually take it off the wall and hand it back to Randy. So it's kind of a handoff between the two of them. But this camera system's great. It came in about 10, 15 years ago. It was added, which I think has been great for people to understand what goes on in the cockpit. It seems like it'd be an easy thing to do, just like an airliner, hop on, sit down, and get ready to go. But it's really a very intricate ballet, making everything work. And the dedicated professionals on the closeout crew team, you heard all these guys are like 15 years, 28 years, 30 years. We've got 3 number ones that are actually working the number 1, 4, and 5 today. So a huge amount of experience, huge amount of talent. I worked with this crew extensively for about 3 or 4 years, and they are one of the most professional and dedicated group of individuals I've ever had the pleasure to work with in my entire career. They know what they're doing. They do it well. They take a tremendous pride in their job, and it's kind of sad to see them doing this for the last time. I know they've all been around for a long time, and they're trying to make this the best one ever and get this crew off safe and sound. And my hat's off to every member of the closeout crew now and the history of the shuttle from the very beginning. They're the ones that take care of the astronauts right before they leave the planet Earth and make sure everything's perfect for them right as they go out the door. So my hat's off to Travis and his whole team today and all the other ones that came before him.
Talking about the cameras that were added, one of the cameras that we get the most comments on that people really watch for now is that pilot's point of view camera as you're coming around the heading alignment circle. Everybody wants to see the shuttle lined up with the runway turning final. It's so impressive.
Yeah, it's always cool to see it from their perspective, or like this, seeing what's going on. It's nice, and we've tried to do that more and more, is give the public more of a view of exactly what's going on. Space is not easy. There's nothing easy about going into space, staying in space, working in space, coming home from space. It's all very, very difficult and requires a huge amount of drive and thousands and thousands of professionals down here on the ground. We see the guys in orange now, or blue flight suits, and and oftentimes they're the focus. But really, the focus should be on the folks like the closeout crew team or all the folks that are in front of us here in the Launch Control Center. Back in the Mission Control Center in Houston, I work there all the time. Butch and MCC, the asset entry, Capcom back there, and the flight directors and flight control team members there, and everybody trying to make this work and get it all good. But it's always great to see that point of view of what's happening, the pointing into the spear, and that is one of the neatest things, is being able to get that HUD camera view coming around. And boy, you see that runway come in sight, and it's a really good thing. Once it gets to this point, after we're done with everybody, there'll be a crew comm check that they go through around the horn to make sure that everybody's good to go. And then actually there's a relatively quiet period on board. Once the hatch is going closed, there'll be a pressurization check. Once the closeout crew gets the hatch closed, there's a pressurization check, which essentially we overpressurize the vehicle to make sure that it's airtight, that there's nothing leaking out. And if it doesn't hold that pressure, we know something's wrong, more than likely with the hatch, but it could be a few things. So they'll do that, and then after that's done, the crew actually sits for a little while, and it gets pretty relaxed on board. Sometimes they're telling jokes. The ICOM actually comes down to a few people on the ground, and so they can talk to a few people on the ground over the intercommunication loops that we actually can't hear. And so it can be a pretty light time. It's kind of your relaxation time before you really get down to business, about half an hour, 45 minutes before the launch. Then you're starting to get locked back in. But it's hard to stay locked in while you're laying on your back for 3 full hours. So we kind of have I wouldn't necessarily call it a break, but it's a little bit of a slower time in the schedule there, where the crew can, check and make sure all their gear is ready to go through all their checklists, look at all the displays, get everything all set up, and get ready to go.
Now, it kind of looks like, looking at the white room, some things are already starting to come out. How soon can they start taking things out as far as removing things that have to be out of there before flight?
We take things out as soon as you can possibly take them out. So once you're done with a piece of gear, it comes out. As a matter of fact, there's a lot of things we haven't seen come out just because we weren't looking at that view. But like, for instance, once the pilot and commander and they've got their protector over their rotational hand controller, which is their stick that they fly with, those come out immediately. So as soon as you're done with a piece of protective gear, as soon as you don't need it to protect anymore, it comes off the vehicle. You don't want to wait till the end. So as you go through, a bunch of stuff's come out. I guess at this point, probably a third of the things have come off the vehicle. And there's a lot of things. We normally have protective stuff on the middeck, which is not required today. So, of course, that stuff never went in. But the last probably 2/3 to half of it comes out when Randy comes out after we're done with the last comm check. And we're getting pretty close to that here. You can see Drew's finishing up work on Rex, and Rex has his helmet on already. Not quite to the gloves yet, but he's finishing up all the connections. So we'll actually, if we get to keep this camera for a little bit, we might not be able to, but you'll actually see Randy start pulling all those pads that they're stepping on. You can see that Drew, number 3's left foot is on a white pad back there that he's stepping on. You've got the window covers that Randy's stepping on. You've got the video cables that we talked about. And then there's actually, to the left of Fergie, there's a plexiglass panel that covers all the circuit breakers over there that has to come out. There were HUD covers that had to come out that get taken off. There were the RHC covers that had to come out. So there's a huge amount of gear that comes out of there.
Well, meanwhile, while all this is going on, the activities here in the firing room continue with the launch team. And we just heard that the Ground Launch Sequencer is ready to support. That's our master computer here in the firing room that'll be controlling the countdown down to T-minus 31 seconds. And that's active now. But the last 31 seconds are actually controlled on board Atlantis, isn't that right?
That's correct. They're actually controlled by the computer. We kind of hand it over to the computer within the last 31 seconds because there's so many things happening so fast that it would be an impossible position to put a person in for them to hit the button to stop things. You just can't process the data that fast. So there's a certain number of things that the ground launch sequencer takes care of that it's essentially getting a go vote from the equipment. It tests the equipment. If it works, then it keep going. If any piece of equipment that's in that GLS sequence goes down or doesn't work correctly, it automatically stops the launch. Now, that doesn't mean that we don't have other ways to stop it. There's, in Launch Control Center here, they can still stop it. If they see something that's outside the ground launch sequencer, like, for instance, an airplane that comes within the no-fly zone or something like that, they can stop the launch from inside the Launch Control Center. On board, also, we can do the same thing, because one of the checks as it goes through is it checks to make sure all the equipment's working. Well, we've actually got a piece of gear on board that we can turn off that's not critical to flight, but if it gets turned off, the GLS will see that and it will stop it. So the crew has a vote as well. If something went wrong inside the cockpit and they thought, hey, inside 31 seconds we don't need to go here, the commander can reach up and throw a switch, which backdoor stops the GLS sequence and you won't launch. So there's still overriding control inside the vehicle and outside the vehicle to stop the launch. There's no overriding to go for the launch. If the GLS says you're not go for launch, it's shutting down, and it's doing its automatic system. And it's built that way specifically because it just can't be done any other way.
Close each here. Standing by. Thank you.
I give you one to think about. A few of these lines were stored without caps on the ends, and I would like to get that configured properly when we put them to bed this time.
OTC, MS2 contact.
Flex line.
MS2 is OTC. I got you loud and clear. How many?
Cap for that one. I think we have caps on it.
Loud and clear also, Roberta. Thanks. Good morning, Red. Good morning.
No caps on the flex line.
So that was our last comm check with the OTC, and you can see Rex after the first comm check is bringing his visor down and locking it with that bar that comes down, and that's what makes the seal airtight. And now he'll be doing his communication check with the NASA test director here at Florida, and then with Mission Control in Houston.
MS2 contact. MS2, this is NTD, and I have you loud and clear. Good morning, Rex. Good morning, Jeff. I have you loud and clear also. MS2 contact.
MC Houston, we read you loud and clear, Rex. Good morning.
Good morning, Butch.
You can kind of see Randy taking the last check here. He's actually standing up and looking at everything. He's making sure that everything's coming out, that the crew has everything where they need it to be, and he's checking to make sure that all the gear comes out. You can see in his left-hand sleeve there, he's got a green glow stick, and all the crew has glow sticks in their sleeves as well. That's in case something happened, all the electrical power is taken off the vehicle. There are glow sticks that are put all around the vehicle, and this especially works at night. During the day, you can see the light coming through the bottom windows. It's not as big of a deal, but once they get into orbit, it could be. If they lost electrical power to the lighting, they've got those so they can see where the hatchways are. They can see their way out. If there's anything happens in the vehicle, they can kind of follow a trail of those to go along. And each crew member wears them as well, because if something were to happen to the closeout crew is looking for them, it's easier to find people, obviously, with that. So they have those not only for here on the ground, but also if they had to go transatlantic aboard or something like that, where the crew actually has to shut the vehicle down. If they were to go over there and say it's dark in Europe and they shut the vehicle down, all the lights go off, you need a little bit of light. So they've all got flashlights as well, but we're always thinking ahead to the next thing, hoping that it doesn't happen. Kind of see in the front there, on the front lower left of the thing, you've got Doug actually has a checklist out and he's looking at it. Fergie's doing the same thing. They're both looking at checklists and talking to each other, getting all ready to go. They're comparing notes, making sure that everything's set on both sides. They've both got the same information down. Even though you've checked it 10 times before, you'll check it again before you go launch, making sure everything's good.
OTC. Go ahead, Ash. OTC, the crew's ready for astrocom and aircraft checks. Okay, and you're going to start with your crew module closeout, right? Say again, OTC? You're going to start with your crew module closeout? Or are you going to wait till after? Okay. We're going to get started on closeout. Alrighty. And CDR on Airground 1, verify all crew members are ready to proceed with astrocom checks. OTC, all crew members are ready. Copy that.
Well, Jim, thanks very much for being with us. We're going to listen now to the comm checks going on with the crew. So thanks for coming by and talking with us.
It's been my pleasure, George. Good to be here. And I'm going to turn over to Tim Seymour, another professional from the closeout crew. The guys I've been talking about, and my best to all those guys, and another great job, and thank you very much.
As needed.
Thanks very much, Jim.
Do not change the audio panel switch configuration. And let's start with T12 since we're already there. Cruise OTC on T12 for comm check. CDL clear. PLT. MS1? MS2. Copy that, and I'm switching to air ground 2. Flight crew, this is OTC on air to ground 2 for comm check.
Yeah, loud and clear. CLP.
MS1, MS2. Copy that. And I'm be switching to UHF. Or ICOM A, I'm sorry, ICOM A.
Houston airlock on 2 for the airlock steps.
Okay, Ron, as the Orbit 1 team discussed with you earlier, we are ready for you to go ahead and take the O2 crossover valve, and that's Victor Lima 011 to open on the airlock spaghetti panel.
Okay, I'm going to do that right now. Houston station, that's complete, and I can hear the flow.
Houston. Houston copies, Ron. Thank you.
No problem.
Yeah, loud and clear. CLP.
MS1, MS2.
Atlantis, Houston, for the CDR and PLT, configure for air to ground 1, comm check.
That didn't work.
Configured. Atlantis, Houston, for the CDR and PLT, comm check on air to ground 1.
CDR loud and clear. PLP loud and clear.
We read you loud and clear also, guys. You can configure now for air to ground 2.
Payload.
And station Munich on 2 for Mike. We have some info on the caps for you.
Atlantis, Houston, for the CDR and PLT, comm check on air to ground 2.
Okay, Mike.
CDR loud and clear. PLP loud and clear.
We read you loud and clear also. You can configure now for air to air.
Caps are missing.
Configured.
Atlantis, Houston, for the CDR and PLT, once more, comm check on air to air.
CDR loud and clear. PLP loud and clear.
And we read you loud and clear also. You can configure now for SIMO voice check.
We recommend to use
It worked.
them instead of the caps and tape them so that the connectors are protected.
Configured.
Atlantis, Houston, for the entire crew, comm check.
CDR loud and clear. PLP. MS1, MS2.
Nice job, Atlantis. We read you loud and clear, and this completes the air-to-ground voice checks.
Of connector caps, I believe. If I find that, can I use those?
And we would have to check on that. The other thing that I wanted to pass on, because we are entering into an LOS period, is that we want to make sure that step 11 and the 12 are done, and the step 13 can be, let's say, dismissed today.
Yeah, step 11 is in work right now. I have clean towel to wrap around the coolant sampling adapter or lure lock interface. And for that, I do have a question. Of course, there's a nice foam cutout that the procedure had been installed a minute ago, but now the current configuration is the cap off the lure lock and the insulating cap foam cutout also off the lure lock. So I wrap this end with the towel and tape it in position. Is that correct?
Mike, that sounds like a good config.
Copy that in work, and also copy step 11 and 12 required, 13 is not.
Good copy, and then of course in the end a lot of storage stuff, and we have some words when you are there, but now everything okay.
OBCC, OTC?
Yes, ma'am.
Okay, they're going to have to change lock pumps. The one that they're on trending towards bad. Anyway, they're switching pumps. There is a very slight possibility they'd have to do a lock vent, which is very loud. Let you guys know, and please let the flight crew know.
All right, I will pass that on right now, so give me a second. Thanks, OTC.
Thank you.
This is Shuttle Launch Control, T-minus 1 hour, 22 minutes, 48 seconds and counting. And as we just heard, we're going to do a little activity out at the pad involving a recirculation pump. And joining us here in the firing room now at the Public Affairs Console is Tim Seymour. He is a closeout crew member, and the closeout crew is about to be briefed on what's going on, and so that they will be fully informed of the activities that for various reasons they may become aware of. So they wanted them fully in the loop as to what was happening, as well as the astronauts on board. So, Tim, could you tell us a little bit about what your understanding is about to happen?
Sure. Good morning, George. Thank you for having me here. The closeout crew will be informed that at the LOX area we have a series of pumps that pump the liquid oxygen up to the vehicle, and we have a bearing problem, temperature with one of the pumps. But what they'll do is NTD will come over and they'll let the OVCC, Travis Thompson, know exactly what's going to happen. There's a possibility there'll be a loud venting noise when they swap over the pump, because they'll have to shut it down, bring the other pump online. Pressure might come up. They might have to vent the LOX tank, and in the event, the crew and our closeout crew in the white room will be able to hear that, because it's right out of the top of the tank, 70 feet above them. The switchover probably won't take very long, and it really won't affect our guys in the white room or the crew. It's a GSE function, and the ground support guys will take care of it in a timely manner, and it won't cause any holdup, I'm sure.
OTC, CST.
They'll be right in and out, and it looks like work in the white room's going right along. Travis has got the crew. They've been pulling potty platforms and some other platforms out. We have a temporary install document that we work to, George, and we make sure everything comes out. And we had 26 line items this morning that were put in the ship, and they're in process of taking part of those out right now.
Well, the crew's on board. They're doing their communications checks with the firing room and mission control in Houston. Right now, the closeout crew right now, they're getting ready to do a number of things. At this point, the items are coming out of the hatch, Tim, right? And then once everything is out, and I gather that's got a while to go yet. There's still a lot of red tag items, I guess, that we heard Jim describe, that the closeout crew has to help with removing. And then what's their next function? What's the next thing they'll do?
Well, once all the appropriate items have been pulled from the ship, George, they'll take and they'll clean the hatch seals. They'll get ready in preparation for the hatch closure. Then they'll go into crew compartment pressurization. They'll hook up the probe. They'll bring up pressure into the crew module. And our NASA quality, Jack Burrett, number 6, that's one of his main objectives and priorities is to make sure that everything is out of that vehicle. We don't want to leave anything in there that's not supposed to be. So between Jack Burrett and Travis Thompson, the OVCC, they concur with each other. As each piece comes out, we check that off one by one, and at the end, they buy that off and verify that everything's out of the ship that needs to be.
Well, Tim, we've got a video of the closeout crew that shows a little bit more of them personally and some of the activities that they did during the terminal countdown demonstration test. So if we could go ahead and roll the tape and tell us who the closeout crew members are that we're seeing.
Okay, George, I'll be happy to do that. Well, obviously, this is Travis Thompson. Travis is our OVCC. Travis is a really close friend of mine. We've been together since Little League Baseball. We've worked together for 30 years. Travis has been an OVCC and a closeout crew member for over 100 launches. Travis was born in Vandenberg Air Force Base. His dad was in the Air Force out there. And this is Drew Billingsley. Drew is one of our insertion techs from Houston. And they call him Hollywood, but he's got a little Hollywood in him. But Drew's very, very professional at what he does. He's a top-notch suit tech. He's right on time. He knows exactly what he's doing, and he makes our job easy. Now, our number 4 is Renee Arians. Renee has been part of the crew for about 20 years, and Renee's done probably over 40 launches himself. Jack Burrett, our NASA quality. Jack's been here for over 20 years, and actually 26 years with NASA. Jack was raised in Melbourne. He was born in Wisconsin and grew up and down in Melbourne and went in the Marine Corps and then came back to work out here at the Space Center with us. Now our number 5 sitting inside the hatch there, that is Chris Meinert. Chris is probably our senior closeout crew guy next to Travis. Chrissy's done a lot of closeouts. I'm guessing probably 60 or 70. Chris was born in Long Beach, California, and grew up in Palmdale. And Chris actually worked in Palmdale at the plant building some of the orbiters in the early days. And this is our ass, Randy Bresnick. And Randy's been part of the astronaut office for at least 7 years and done 5 other launches. Ray Cuevas is our other suit tech from Houston. And Ray's been with us for 14 years, I think, as a closeout crew guy. And he's worked a total of 28 years and has done 17 launches, as a matter of fact.
And here we are back live in the White Room. Still, we can see them taking out some emergency breathing air packs right now.
Yeah, Randy just came out. They finished their air-to-ground checks. Randy brought the comm out. You see Renee just pulled what we call the diving board. Drew's taken that gold-looking piece of equipment out. That's the diving board that goes across from the White Room into the vehicle. That makes egress and ingress out of the vehicle much easier. The big yellow hose, that supplies air, cooling air, into the crew module.
NOTC OVCC.
Go ahead, OVCC.
Yeah.
Ma'am, my TIRs are clear. My ass has left the ship. I'm getting ready for hatch closure.
Okay.
Yeah, like I just said, I heard him talk to Travis. George, we've got all the TIRs. Everything that's tempororily installed
Sounds
has
like
come
they're
out.
Getting ready for hatch closure.
And
So
we're going into hatch closure.
you have all non-flight items removed, including the ass, huh?
That's affirmative.
Okay.
What you see now, George, is Chris, the number 5, is wiping the seals on the hatch. That seal, when we pressurize the crew module, keeps that valuable pressure inside the crew module. A single hair could cause it to fail, and we'd have to go back in and repressurize. Now, NASA Quality is looking at the seal as Chris cleans it, number 6, Jack Burrett. And now Chris is going to the board side of the ship, the onboard hatch, the inner seal, and he'll be wiping that down. They've already pulled the protective cover and the tape off of it, and Chrissy's actually cleaning that seal now in preparations for closing the hatch. Renee's just holding the air hose to keep them cooled off. It gets a little warm up there when you start working around in tight quarters with 4 or 5 people standing there. But Chris is doing a really detailed inspection.
This is CNC. Yeah, you ready for a momentary loss or downlift? I can verify that we can lose downlift in the next 3 minutes. Okay.
So Chrissy's finished wiping.
NOTC OVCC. I'm ready for 769. That's your call.
Yeah, we just heard confirmation that they're ready for hatch closure. About what temperature do they keep it in the White Room?
About 76, 74 degrees.
You want to go to 142 with AFM?
Yes, ma'am. It's your concurrent.
All right, I'll send the QC over there. CMQC OTC? Go ahead. I need somebody on 142 with op 267 AFM. Copy. And TVD OTC?
No copy. TVD?
Yeah, you ready for opening the vent doors?
Yes.
Okay. And CGLS OTC?
Yeah, let's go.
Orbiter vent doors will be moved momentarily, step 765.
Yes, ma'am. We copy. Thank you.
Okay. And TVD, you've got to go.
Okay, for 764, please record left hand. Or current ship position of vent door is in purge position.
Purge, okay.
Can you explain a little bit about what we just heard?
Copy.
Heard there about the vent doors?
Yeah, as we just heard, George, they were talking to vent door positioning, which is critical to keeping the vehicle in a certain pressurization point. Those doors open and close. We close them completely, partial open, full open, and it helps with the purge on the vehicle. They just got to go to close the hatch. Chris and Renee have closed the hatch at this time, and it looks like they're probably, they're going to put on the carrier panel that covers that portion. They pulled the handle off, our GSE piece that we use to handle the hatch.
Go ahead, CBD.
768, leeward vent doors open.
Okay. OVC, COTC.
On 2 for the node 3 Alpha 2 cleanout.
Hello.
Go ahead, Ron.
Hey, Robert, just want to give you a tag up on that. As I called on earlier today, step 1 is complete. I've been trying to chip away at step 2 throughout the day, and I've stood down for that for now. I estimate I have about another 45 minutes of that.
Okay, and back to like I was saying, you see Renee walking out there. That's our GSE hatch handle that we use, George, to close and open the hatch. They've got that off, and there's protective tile that goes back over those two places that that Renee and Chris will put on. Once the handle's taken off, it gives you access to where we can go into pressurization. That'll be one of the next things they do is they'll pull the big line off the ceiling. We'll hook it up to the hatch, and we'll pressurize the vehicle, kind of like they do with an airliner. When you get ready to go up on an airliner, they pressurize the cabin, and we do the exact same thing on the shuttle. Now we've got everybody in the white room now. Ray Cuevas and Drew Billingsley and Randy. Randy's holding the hose. They don't want to leave Randy out. They want to give him something to do, so they're letting Randy hold the hose. And you see Travis is walking back and forth. Our OVCC is telling the guys that are actually doing the work that they have a go to do certain things. Everything comes from the OTC or the NTD telling we have a go for this. So that's exactly what Travis is telling those guys. Okay, you've got to go to do the hatch, do your pressurization, do your carrier panels, whatever the sequence of events that comes through from OTC goes through the OVCC and then on to the number 4 and 5 that do all the mechanical work on the hatch itself. And our NASA quality is right there with them. You really can't see Jack, but he's standing in front of Randy, and he's watching what Chris is doing right now, and Renee is talking to ECL, probably going to bring up pressure, getting ready to do pressurization of the crew module. I know what they're doing now. Yeah, at this time, I see now, George, they're doing the seal leak check. When I told you before that Chris was wiping down those seals, we take a handheld unit and we pressurize between those seals. And what we do there is we're verifying we don't have a leak. So there's a time frame that we pump up, we bring up to pressure. We shut the pressure off, and we do a decay check, basically, where if we're allowed 1 psi drop in 2 minutes, as long as we don't go below that 1 psi drop, we've got a good seal, everything's holding the hatch, everything's sealed tight. That's exactly what we want to see.
And did they see if that's correct, or is that being conveyed from the firing room tells them that that is good and correct, or how do they know, how do they get the word that it's good?
Well, we work to a procedure there.
Step 780 is complete. I am user in alignment maintenance mode.
Thank you.
So we've got a procedure, like a checklist that we go through, and that calls out the parameters that we're allowed to. Our GSE piece of equipment is ready and charged when we go to the hatch. We put it on, we open the valve, it pressurizes a very small space around the hatch. And we're allowed an allowable leak rate, but it can't go beyond a certain point. If it does, then that means we have dirt.
OVCC on 212. Go ahead. Yes, ma'am. Hatch is closed and latch for flight. Ready for cabin leak check. Okay. That's also 16774 in your dot 2. Okay. And just to let you know, we did reposition the vent doors. Leeward vent door opening is complete. I copy that.
They just...
and I do have a buy for you if you want me to go to 132. If the MTC's still there, I got a dot 100 buy for part C. And CMTC, do we still have somebody monitoring 132?
It would be me.
I'll meet you there real quick.
Copy.
Yeah, so the OVCC just called in that they have the hatch latched and locked, good seal leak check, and the next thing will go into hatch pressurization.
CDR and ECL, stand by to perform cabin leak check. Master alarm and light will come on as a function of high cabin pressure. CDR, you should notify ECL that we've got the alarm and you can reset when you get it.
CDR, copy.
And CDR, you have a go to perform cabin leak check per your checklist.
Good work.
Okay, George, what they've done, they've got the okay from OTC to start cabin pressurization.
OTC, CDR, the L2 steps are complete and cabin leak check.
Copy that. And ECL, OTC?
ECL.
You've got to go on 778.
Copy, that's in work.
And you'll need one of the techs on 143 with you?
That's affirmative. I think we have them.
All right. And OVCC, you got somebody on 143?
Back on 212, yes, we do on 143.
So they're all participating in this.
Yeah, it takes all of them to do this portion here, George, and OTC gave them the go. Our number 4, Renee, is going to be running the panel, which that gives the pressure through the hose into the crew module. And like they were saying, the commander will get a series of alarms of overpressure going off in the cabin, which he will just nullify the caution and warning alarms, and will pressurize right on up to 15 pounds. And that's what Chris is getting ready to do up on the hatch now, is they will hook that pressurization hose up, and Renee, with ECL Engineering, in direction, over the net.
OTC?
Yes, ma'am.
You got somebody over on 143, right?
That's firm.
Okay.
Renee will be talking to ECL Engineering, and she will give him the direction of where he needs to go, what valves he needs to open, and what pressure they're expecting to see. At that point, we'll pressurize the vehicle, and we'll get it all ready for the crew. And at that time, you see the cap Renee has in his hand right now. That's the cap that will go over the pressurization port. It's just basically a hole in the hatch that once we pull the probe out, it's been putting pressure in the vehicle, that cap right there goes on. That's one of the last pieces of hardware that we put on the vehicle right there, that cap. And that cap has 2 O-rings in it, and it's not torqued like a lot of things. That cap is basically hand tight, as tight as we can get it by hand. And once it's on, that's the way it'll remain all through the flight. And that'll be one of the first things they take off when they get back. Once they get the carrier panel off, that comes back out, and that'll all be taken off when we get back on the runway. It looks like Travis is up with a hatch with Chris giving a hand too. It takes just about everybody to do this, George. OVCC's up there because Renee's running the panel. You see the NASA qualities going over the steps with Renee on the book through engineering direction. And we've also got a hard copy up there in case there's any kind of comm loss or anything. That way they know exactly where they're at in the book, and they can disseminate that back to the OTC and ECL Engineering that's directing them to do this job at the time right now. It looks like they've given Chris a go. I think he's got the he's got the hose in his hand. He and Renee, they'll be putting this, it's about a 1-inch braided flex hose with a series of fittings and a little bitty probe that goes through the hatch into the crew module. And, that's what Chris is doing right now. He's hooking that up. We take and we count the threads, George, when we screw that on. When we get ready to take it off, we know exactly when we get to that last thread. And that way when we pop it off, we don't want to lose any pressure out of the crew module more than we have to.
I think I'm going to mention real quick, we just hit T-minus 1 hour and counting in the countdown, so that puts us just a little less than 2 hours for launch, considering the built-in holes remaining at T-minus 20 minutes and T-minus 9 minutes. But the good word is right now that everything is still pressing on as planned for an 11:26, and we get down to T-minus 9 minutes. That we'll be taking a good hard look at where everything stands, particularly as far as the weather goes. But looks like, Tim, they're hard at it right there.
Yes, sir, they are, George. This is one of the final preps. Actually, it's the last thing that we'll do inside that's actually going into the crew module. It's air, and Renee is talking to engineering. Chris and Travis are over there, and they've got the probe hooked up, and they'll sense the pressure inside the crew module. And ECL will tell them, and Renee will back the pressure down. And once they get to the pressure that they're looking for, that probe will be disconnected, and the hatch cap, what we call the hatch cap, will be put on. And that's all done within just a matter of seconds, because we can't lose too much volume of air out of the cabin, or we'd have to go back and repressurize it again. And we all train for this. We've done it 100 times, and it's a coordination between the 4 and 5. When the 5 pulls a hose, the 4 puts a cap on, and you're right there together. And there's a considerable amount of pressure blowing that back off. And once the probe is pulled off, you try to get that cap as quick as you can.
Go ahead.
Yes, we need a panel reading from the crew.
All right.
CDR, ECL.
Go ahead. It's cabin pressure 14.9 on the gauge.
Copy, 14.9. Thank you. OTC detail.
Right, ECL.
Just a heads up, we're about to begin pressurization. There will be a master alarm and klaxon.
Copy. CDR, you copy?
We copy OTC, thanks.
Okay, George, it sounds like they just got the go, so they're going to start bringing up pressure. The commander gave them the pressure inside the vehicle right now. ECL's calculating that pressure. They'll open the gauge, they'll open the valve, and they'll start pressurizing the crew module. That's what Renee's doing right now. He's talking to ECL engineering. The probe's hooked up. They're ready for pressurization.
CCSE and RCRT, OTC.
CCSE.
Yeah, can you guys go to 232 for a span of high power?
Yes, ma'am.
And Tim, what they're about to do right now is to take the Mila tracking station. The big tracking antennas are now going to be going from low power to the high power mode. So that's what that direction was, because that's about to happen. Usually happens at about 55 minutes, T-minus 55, and we're coming up on that in about 40 seconds.
So that's the Mila tracking station.
Station Munich for Mike on 2.
Go ahead.
Okay, George, that the big hose, the yellow hose is nothing more than an air conditioning hose. They're keeping the crew in the white room, the closeout crew, in the white room cool down. That's the only air that we really have in there right now because the ducts have been diverted and all the air is coming out of the yellow duct. And that's why Randy's holding it, pointing it towards the guys, trying to keep them cooled off because it's pretty warm in there right now. I imagine it's probably close to 80 degrees. And as you see, Drew's putting on his lap pack. So that means we're getting pretty close, George, to getting to where we want to be this morning with the closeout crew. Drew and Ray will take the final pieces and parts out of the white room. They'll put
OTC, we received and silenced the master alarm.
Copy that. Thank you.
the number 6 and the number 4 are donning safety harnesses. As you see the green harness that Jack's putting on right now, and Renee will have one, that's for breaking the white room down. Opening the doors, closing doors, breaking it down, getting it ready for launch.
So is this harness, is this for them or is this for the equipment? It looks like it's for them. They're putting it on. Okay.
Yeah, the green harness that NASA's putting on right there, once they open the big door where the hatch is, it's a long ways to the ground from there, George. It's 195 feet to the top of the MLP. So they'll hook off to the ceiling on approved tie-off points, and then that door will it'll come back to the right, and the other door will come back to the left, and they'll open and they'll put a handrail out. If in the event that the crew would have to get out without us there, we extend a handrail out, they blow the hatch open, the arm will swing back, they'll be able to get out safely. Now, the diving board won't be there like we talked earlier, that big gold diving board. We put it in a locker so the crew knows. They train. We train on the pad with them, and they know they got to crawl across that threshold where there will be nothing at that time.
Once the orbiter access arm is back, if they have to put it back into position because there's been some kind of emergency, something goes wrong, have you any idea how long it takes to put that orbiter access arm back in place?
Yeah, George, we have what they call an emergency extend. It goes into a full mode, no restriction, and the arm can extend back in less than 10 seconds. From the time they energize it to its full back against the vehicle, it only takes about 10 seconds. Now on launch, when they rotate it back, it's nice and easy, it's methodical, it comes back. But in the emergency event, that we've got a mode and we go into emergency extend, and it's there now. I mean, if the crew could get out, when they extended that arm, they couldn't get out as quick as the arm could be there. And that's what Renee and Jack are doing now with their harnesses. You know, when those doors and the dock seals are all deflated, the protective cover.
OTC.
And for the restore in general, I think we have only one top priority item that needs to be handled for ULF7. These are the line items 35 and 36, but I think that...
CCME, OTC.
CCME.
Yeah, we're ready for 807, our source verification.
Yeah, we'll be doing number 1 on that.
Number 1?
Yes.
Okay.
It is not performed.
All right.
Renee's putting a protective cover over the ELSA rack there, George. Those are the ELSAs that we put in the vehicle. When the crew's getting strapped in, we have a ELSA in there for every person that's in the vehicle at that time. In case we'd have an O2 deficiency, they could grab an ELSA and breathe.
Emergency breathing air.
It's emergency breathing air, exactly right.
And that's Roberta Wyrick from United Space Alliance, who's the orbiter test conductor that we've been hearing interacting with the closeout crew and with the flight crew while all of this is going on.
Yeah, we worked a lot with Roberta over the last 30 years, and she's been here a long time, and she keeps us straight and lets us know what's going on when we need to know it, and very helpful for the closeout crew because she keeps them abreast like the guys going out to fix the LOX pump. You know, they knew there was no second guessing. They weren't alarmed by venting. But you know, Roberta's worked with us for an awful long time, and all our guys are very appreciative of Roberta and her whole group. The OTC office all does a fine job for the closeout crew guys because we're out there by ourselves. You know, there's nobody else there with us, but so they keep us abreast of what's going on around us. You're kind of in a confined space there in the white room. Yeah, there's an awful lot of work that goes on there in a short period of time, George. You know, from the time that we get to go to close the hatch, you're making sure everything's done. You know, and as the folks out there can see, that that silver hose that's hooked up to the hatch, that'll be the last piece of equipment that's actually hooked to the vehicle before launch. We take that off. The closeout crew takes that down. They put a cap on. They put a carrier panel on, and that's the last piece of flight hardware that'll be put on the vehicle for this flight. And that's part of the closeout crew. You know, when you put that last piece of hardware on, you go through your mind, we all do it, that everything is done just perfect as we can make it. Because when we walk out of the white room, we got to know that things are just right. And all of the fellows that are up there today have done this many, many times. And unfortunately, it'll be their last time of doing it. And but I can guarantee it'll be done right. You know, these three guys that we have in our NASA quality are all very experienced and are very good at their jobs. And I've worked with them all for 30 years, so it's going to be a great day, especially if we get to launch. And I think the weather's probably going to help us out a little bit, George, and we'll get to do
Starting
this
to look
today.
a little more optimistic. We live in hope here. So they go back when they leave the white room. Where do they go to?
Correct. Our RF SEP verification is complete.
Copy that.
Once we leave the white room, George, we'll go down to the closeout crew truck. We'll elevator, and you know, we've got just a few minutes to depart the pad. We normally stop at the top of the pad and gaze back at the vehicle one last time, make sure everything's right, you know, because the RSS is back, and we look at it, and everything's just pristine, you know. And my last one was a night launch, and that's really pretty with the lights on it. But today, hopefully, the sun will shine on us, and we'll get it done. And once we leave the white room, we go down and we pack our truck up. And from there,
Yes, ma'am, go ahead.
Got to go on 8:58 mainline activation protocol.
Protocol.
and then once we leave the pad, George, we come back. You can see out the firing room windows here. We park at the AB-11, and we park the closeout crew truck. The OVCC hooks up OIS. He tells the launch director and NTD that we're back, and we tell them when we leave the pad, and then once we get back there, we're stationed in the event that if we would have to go back to the pad in an emergency situation, or just very quickly go back to the pad.
CTS. You ready for step 870 or LVD redundancy check?
That's fine.
You need a QC? Okay.
Yeah, and I think we also heard them say they could pick up with activating the ground launch sequencer at the nominal point in the countdown, so that's another encouraging sign that there is no reason not to continue to press on down to T-minus 9 minutes.
Yep, that's a good sign.
OTC, TGLS on 212.
Go ahead, GLS.
Yes, ma'am. GLS mainline activation is complete. That's steps 859 through 864, and 861 is as listed.
Copy as listed.
So are they getting close to where they would be leaving the right room at this point, or they still have more to do?
They still got about 10 minutes worth of work to do, George, after they pull the probe off the hatch.
ACL, OTC.
ECL.
How are we doing on crew module prep?
It's still in work.
Okay. Any estimate?
I will need about 5 or 6 more minutes.
All right, no problem.
Okay, George, sound like we just got word from ECL Engineering that we got about 5 or 6 more minutes in the pressurization of the crew module. And at that time, Renee will bring the pressure off the panel. Chris will disconnect the hose, and they'll put that cap ready for flight. And after that, we'll have about 5 minutes, 8 minutes it takes to break the white room down. Jack Burt and Renee, that you can see with their safety harnesses on, they'll be the two breaking the white room down. And then once the white room's broke down, the OBCC goes through, makes one scan, makes sure nothing's left in the white room, no FOD, everything's cleared out, and that'll be the last thing that the closeout crew will do in breaking the white room down and making sure everything's out of the white room. So it won't take long, and they'll be...
Well, Tim, we just got some good news about that pump change out that we had going on underway out at the pad. Tell us what we've learned.
Well, they had a successful changeover, George. They went to the other redundant pump, and the temperature was going down, and they decided to do the changeover. And that pump's up, running. Temperatures are all good. We got a few more minutes before the temperature actually will come up to where they want it to stabilize at, but it looks like everything's going and coming right up to where they want it to be. That's why we have 2 sets of pumps. That way we got 2 motors, 2 pumps. That way if we have a problem, just like that, it's a short fix, a quick changeover. And, without that, we might not have launched today if we only had 1. That's why we got redundancies almost everything that we do. So it's a good thing we had another pump today at the LOX area.
And so that they actually removed and replaced it and put in another one.
Actually, all we had to do, they had to go in and just change over. They wasn't actually a physical change. They just redirect the from pump 1 to pump 2.
Oh, okay.
It's just a quick changeover. It wasn't like they had to unbolt that pump, put another pump in. There's actually a pump there, but they got to do some valve diverting in order to do that.
Okay.
Those pumps were changed out about 15 years ago, George, or better. I worked that system for a while, and we did that back when I was there, as a matter of fact. We put new motors, new pumps, and all in. Okay, looks like they got to go. I didn't hear them, but I think they said they had to go for... Yeah, it looks like, George, we got to go. Renee and Chrissy are going to take the pressurization hose off the hatch at this time. Renee's pulling the hose off, and Chris is going to put the cap back on.
OTC CNC.
All right.
Page 1177. Did we give completions on all that?
Yes,
And step 16861, that was performed.
Yeah, and as written, just with the 1X there, the one bypass.
Copy that, thank you.
Okay, George, Renee just pulled the pressurization hose off. There's a good shot of it right there. Kind of looks like a pistol grip and a safety protector that he's putting over it right now. It's actually a little 1/4-inch piece of tubing that goes through that port, you know, with a large adapter. And the number 5, Chris Meinert, is putting the hatch cap over the port, and ECL and the commander will come up and tell them where we're at in pressure. And the way the exchange went there looked like we probably didn't lose anything at all, hardly. So with all probability, everything will be just fine. They'll give them a go to put a carrier panel on, and they'll start breaking the white room down, and closeout crew will be out of there in a short period of time. They just disconnected it from the ceiling. As you see Ray Cuevas there, you know, it's a whole team effort with these guys. Everybody's got a little piece of the part they need to do. And Ray and Drew are wrapping that hose up. They're going to put it in a storage cabinet there behind where the OVCC stands. And Chris is actually doing the safety wire now on the cap. Like I said, that cap is hand tight. Where everything else on the orbiter just about is all torqued, that cap is actually hand tight. But once it's hand tight on, Chris will safety wire it with a piece of safety wire, which will hold it in place where it won't come off. And the carrier panel goes over it, so there's no way for it to escape if it were to come off, but we've never had one come off. So, but it looks like Chrissy's got it safety wired, and they'll go in. Renee's looking at the hardware now for the carrier panels. There's 8 screws and washers that go on the carrier panel, and once he gets those ready, they'll take that carrier panel, they'll put their protective gloves on to keep your oils off your skin. We don't touch the carrier panels or the tile on the orbiter with our bare skin. We do it with gloves on. So once Chrissy has that all safety wired on, and next thing they'll do, they'll give them a go, and they'll put the carrier panel on. And looks like they're probably going to start getting ready to take the air conditioning away from them. So it'll get hot in there in a little bit. But I see Jack Bird, our NASA quality. He's in the corner of your picture there. You can see he's probably going over the last bit of look-see.
Go ahead, ma'am.
Yeah, step 890. Now that the hatch is closed, can we get that step from you?
Make sure we understand it. Maybe include some words like things that are hooked together when we go to retrieve them next time.
Copy that. I can give you step 90.
890, thank you.
And Robert, it's great talking to you on the space ground, man.
Always glad to talk to a fellow Aggie in space.
Yeah, Chris just finished what we call a Bergen safety wire tool, George. I seen him walk back with it. He's got the hatch cap on and safety wired.
CGLS OTC.
That's 212.
Yeah, GLS, you can verify 887, is that correct?
Labeled FSS
Please.
77 jumpers, but only one of them fits in because the second one is left configured with a couple of other pieces of hardware for thermal expansion control. This is the 77-2, and this time it's stored together with them.
You see the red streamer on the hatch there, George?
CTLS on 212.
Go ahead.
Yes, ma'am, that is verified.
Thank you.
You know what that red streamer is?
I would assume it's a remove before flight tag.
That's exactly right, and it's on the hatch window. And you know, that little bitty window is the most optically clear window in the whole vehicle. It is as perfect a piece of glass as you can get, and it's in the hatch. That's why that cover's the last cover that we take off. All the mechanical doing are done. We wouldn't want to scratch that window whatsoever. A lot of our great photos that come from space, they actually take out of the side hatch window.
Really, right through the hatch window.
Right through the hatch window, because it is so optically clear. It's amazing. But Jack verified Chris's safety wire job, that the cap's safety wired on. He's going through his book right now, making sure that all those steps are bought off and complete, and he's giving them a go to put the carrier panels on.
OTC, CTLS on 212.
Go ahead, GLS.
Yes, ma'am, I've got a couple steps to buy off with you if you've got some available time.
Okay, go ahead.
Copy. We have steps 814 through 820 complete, and I've got some fill-ins for you if you're ready to copy.
QC, you ready?
QC ready.
Go ahead, GLS.
Yes, ma'am. On 814, the first fill-in should be 0 hours, 9 minutes, 6 seconds. That's for window open. For preferred, it would be 0 hours, 4 minutes, 33 seconds. On 818, step 818, for the T-minus 20-minute hold, that will be 0 hours, 10 minutes, 0 seconds. And for T-minus 9-minute hold, the time remaining shall be 0 hours, 41 minutes, 13 seconds. And for preferred, 45 minutes and 46 seconds.
35 or 45?
45 minutes, 46 seconds.
Okay, thank you.
Yes, ma'am. That should be it.
Thank you.
So that last preferred was 004546.
That's correct.
Copy. OTC ECL.
Go ahead, ECL.
I can give you step 865, crew module pressurization and initial cabin integrity check is complete. We're ready to proceed with cabin vent redundancy.
Okay. CDR, OTC, perform cabin vent redundancy per your checklist.
Yeah, what we just heard, George, was that the cabin pressurization all went well. The CDR shows good pressure in the crew module. And OTC.
OTC cabin vent redundancy config is complete.
Copy that. UCL, you copy?
UCL copies.
So all of our pressurization is good inside the crew module. The vehicle's pressurized and ready for flight. And it looks like Chris is putting the last carrier panel on at this time. He's got, actually there's only one carrier panel now. Back when we started we had 2 carrier panels, and we were able to go away from the old style hatch handle, and the new handle we only got 1 carrier panel to put on, which was a big relief. We've had more than one time where fastener would gald and we'd have a problem, and so we took out half of that equation by going back to 1 carrier panel.
OTC, good day.
Go ahead.
Step 16-866. We show that complete, correct?
That's complete, yes.
Copy that, thank you.
CDR, OTC,
CDR,
perform past BFS transfer prep per your checklist.
PFS transfer, A1.
OVCC, OTC.
Yes, ma'am.
Looks like you're working ahead, but you've got to go to close out the white room.
Thank you very much. OTC past DFS transfer prep complete. And waiting on the answers.
All right. And you have a go for OHMS GN2 press per your checklist.
OHMS GN2 question mark.
And PLT OTC?
Go ahead.
Got to go for water spray boiler GN2 supply activation per your checklist.
Put that work. OTC OHMS GN2 quest is complete.
Copy that.
Water spray boiler GN2 supply activation complete.
Copy that, thank you. CDPS, can you give me step 909?
I can verify step 909.
Thank you.
Houston station on 2.
And that takes care of 910.
Robotics workstation video check.
840, can you verify 922?
That's verified.
Okay, thank you.
Okay, George, they gave him a go to close out the white room. Chris just took the protective cover off of window 11, and they'll start into breaking the white room down.
And we copy that. Good news, Satoshi.
ETSEC.
EP, go.
Max pre-flight bite, step 930.
Copy, work.
Could you say that again?
Yeah, Renee's hooked into the ceiling at this time, and Jack will hook in right in front of him. And they'll...
HDOTC.
Data application. Could you explain what it is? I mean, that I see only good.
PHDOTC.
1, 2, and 3 now.
Go ahead.
Step 935.
On a different laptop, the DOUG, the DUG application, your DUG software.
We'll put that in work.
Thank you.
Application is still running on the DUG machine. Should be in the cupola there with you.
OTC CTLS on 212.
Go ahead.
TLS limit change to dual notification for BRS is complete. That's step 936.
Copy.
On SSC 17.
Do you know if it was shut down by a member of the crew or did it stop on its own?
I did not OFS, but I need to ask, so stand by. And one more question. Would you like me to power off that cupola BCP?
Okay, they did the group photo for us there, George, and they got all 7 of them in, and I hope it didn't break the camera. As you see there...
standby for Simo airground voice check.
Standby.
Well, Tim, they're wrapping up the white room now, so we can see that underway. The crew's about to do their air-ground voice checks, so we're going to thank you very much
Atlantis,
for coming by
Houston
at
for
this
the
point.
entire crew. Com check.
Thank you, George, for having me today. It's been a pleasure.
CDR loud and clear. Yeah, okay.
Hey, that's one. I have to.
Atlantis, Houston, we read you all loud and clear. And we are ready now for updates. The first one is your altimeter setting on page 1-10. And that setting is 29.96. Okay, Butch, we have T996. That's a good readback, Atlantis. The next update is on flipbook, page 2-4.
Go ahead, Satoshi.
Alright, copy. All right, your no-com mode boundaries updates are press to ATO 104 or 10.5. Your single engine ops 3 109, we're going to leave at 12.3. Press to MECO 104, 14.4. Single engine press 104 will be 17.4. Okay, press to ATO 10.5, press to MECO 14.4, single engine press 17.4. Again, a good readback. The next update, the next page on 2-5. Your throttle bucket updates. Throttle down will be at 0.96 Mach. Throttle up will be at 1.35 Mach. Okay, throttle down 0.96, throttle up 1.35. Again, good readback, Fergie, and this completes your Ascent checklist updates. Copy, all those things.
CDR-OTC.
Go ahead, OTC.
Perform cabin vent per your checklist.
That's it, work.
Same QC, step 899 will be not performed.
Sorry.
OTC, Pete.
Go ahead.
I can use steps 931 through 934. Mech pre-flight by evaluation complete, no mech failures.
Copy that. Thank you.
OTC cabin vent is complete. We received a klaxon and we silenced it.
Thank you. And ECL, stand by to give ProWords closed cabin vents on 212 if you see a decrease in TPO2 below the baseline.
ECL copies.
And attention all personnel, our countdown clock will hold in 1 minute and 30 seconds at T-minus 20.
TWS OTC?
Go ahead.
Can you verify 918?
Verified.
And we're standing by to go into the hold at T-minus 20 minutes and 15 seconds. This will be a 10-minute built-in hold.
Attention all personnel, countdown clock at T-minus 20 minutes and holding. Duration of that hold will be 10
And
minutes.
we are now at T-minus 20 minutes and holding. This is a 10-minute built-in hold. Closeout crew still wrapping up in the white room.
Hey, Robert, there was a lot of adjustments and back and forth on item 447. So I just want to make sure that we're all on the same sheet of music and back up with you. So, item
All personnel or all order systems verify program software report only if any discrepancies.
half CTB serial number 1058. And inside that half CTB...
CRPS OTC?
CRPS.
Step 968?
968 is complete.
Copy.
And that half
GLP Papa 1 Delta.
Hello, TCO, VCC.
GLP Papa 1 Delta.
Go ahead.
Not in
Yeah,
the
267 is complete. I can give you the last,
447 Bravo, which is now labeled
I'll have my book.
660.
Okay, so you're saying that you are completely closed out and you're ready to leave the white room.
Copy that. That's what we were expecting. Thanks.
Yes, ma'am.
Just wanted to double check. I thought you guys were up to speed.
This is Shuttle Launch Control, T-minus 20 minutes in holding with 8 minutes and 30 seconds remaining in this built-in hold. And joining us now here in the firing room is Hugh Harris. He was the flight commentator for STS-1, the very first space shuttle launch. And Hugh, it's very it's gratifying that you're able to be here for this, because this means that you've been able to witness the entire history of the shuttle program, and were the first commentator for STS-1 for Columbia. And Hugh, we've got a short tape that we want to play right now because it shows Columbia being launched and your last few minutes doing the liftoff.
T-minus 20 seconds and counting. T-minus 15, 14, 13, T-minus 10, 9, 8, 7, 6, 5, 4. We've gone for main engine start. We have main engine start. America's first space shuttle. And the shuttle has cleared the tower.
Well, Hugh, what are your recollections of that first countdown?
Well, I think that it was just fantastic to be here for the first one, and I was a little bit nervous. You may have noticed that I missed by a second the main engines lighting up, but this was an exciting place to be, and seeing it get off the ground after all of the years and all of the thousands of people who worked on it was just tremendous.
Well, I can remember when you were preparing for that launch commentary for STS-1. I can remember seeing you in your office working on that. I mean, there were papers all around your computer and you're working away. I mean, there's so much going in to prepare for that. And then later, I can remember when you were actually going over the firing room to actually do the commentary, and there was a humongous notebook. This is the White Room clue, doing a quick sayonara here. I did want to catch that.
Just some straight-on shots of each of the screens and maybe some angle shots to try and see if there's any debris sticking out from the screens. Is that what you're looking for?
And Ron, it sounds perfect. Thank you.
Thanks.
And that's a final goodbye from our closeout crew. We did want to catch that since that was going on. But anyway, I can remember you going over to the firing with this humongous notebook filled with all of these notes and your commentary and everything like that. And of course, you had to go through it more than once, as I recall.
Yes, and the reason I had so many notes was that unlike today, the communications were not nearly as extensive. And George Page, who was a very tough launch director, had decreed that we would not talk to anybody in the firing room no matter what happened. So I needed to have the phone numbers of people outside the firing room who might know about a particular system in case something went wrong. And as you recall, on that very first countdown, something did go wrong. Computers were out of sync with each other, and that was something that was pretty difficult for everybody to instantly realize, but we did scrub that day.
Well, I can certainly remember my first launch commentary, which was STS 27, and you were sitting right here next to me, and it was an Atlantis flight. So that's not lost on me that my first launch commentary was Atlantis, and the last one would be Atlantis as well. And it was a Department of Defense mission. And it's funny, I can't recall the number of commentaries that I've done over the years, but somehow that very first one is still in my mind, almost like it was yesterday, as many years ago as it can be. I can clearly recall the entire activity.
Well, on the DoD launches, we didn't give you much to say because people weren't supposed to know in real time. And that's what this job really is all about, is keeping the news media, the American people, informed on a second-by-second basis as to exactly what is happening. And that's really pure journalism in a lot of ways.
And our window closes at 15:31:19.
Well, I think we're about to reach the close of a program that's it's a very storied program. And I think we look back at all of the things that the shuttle has done, the astronauts have done, because it means we had
involved in our launch window today.
Initially delivering satellites to orbit, we deployed the Hubble Space Telescope, we did all the servicing missions, we went to Mir, we did the space station, we did the Space Lab flights. It is so broad, and it really just kind of has set the stage for what we'll be doing next as we go on.
Well, the important thing to remember is that going to space is really all about the people on Earth. What we're learning is more and more about the environment we live in, and the technology that comes from the space program benefits every single person in this country and really around the world.
Well, Hugh, thanks very much for coming by. It's quite a pleasure to be able to chat with you and actually recall STS-1 and to know that we were both here for the first one and we're here for the last one. So, thank you very much.
Welcome, George.
CGSS OTC.
Good.
You can start your second HDU pump, step 1030.
And attention console operators, discontinue all LDB commands and reads during pass ops transition.
ECL OTC.
ECL.
How are we doing on cabin vent?
I was just about to give you 947.
Okay.
Fill in for 948 is 14.75.
CDR, report cabin press per your checklist, please.
The countdown clock will resume on my mark. 3, 2, 1, mark.
And we are now at T-minus 20 minutes and counting. Our next hold is at T-minus 9 minutes.
Cabin press from CST3 is 14.75. On 01, it's 14.9.
14.75, 14.9. And close the cabin vent valves per your checklist.
CDR 1.
NTD SRO 212.
Go SRO.
Range status is go. Weather reports that are clear on all constraints. Range status is go.
NTD copies, thank you.
ETL OTC?
ETL.
Let me know when you can verify 952.
That's verified.
Thank you.
OTC closing in, valves complete.
Copy that. Thank you.
OTC DPS.
DPS.
CDSEP 1035, pass ops transition complete. DPS ready for BSS transition to ops 101.
NTD, OTC, copy.
NTD copies.
CDR, OTC, clear pass fault sum, and take BFS to ops 1 per your checklist.
Clear pass fault sum, and I will take the BFS to ops 1.
Space to ground 2 for Mike and your timeline. Hey, Mike, just looking ahead to the rest of your day, we know it's been a pretty busy day with you with stowage and all, and we do have some important things for you today with the medical ops with Ron and then some Melfi activities later. We just want you to know that we can give up some of the pre-pack times that you have a chance to take a break and have some lunch today.
NTD, Milo, 212.
So pre-pack times are flat.
Go ahead, Milo.
Our data comm switch is hung up and we need to reset software.
All right, Milo, can you repeat what you have there in the SCE? Are you with us?
Copy that.
And CCSE, I guess, if you're listening as well. Milo, what did you say you had?
Our data comm switch has hung up and we need to reset the software.
Okay, what will be the impact of resetting that software?
No connections lost will allow us to make connections when the loss.
Okay, is this an action that needs to be taken immediately, or can we stop and talk about it for a minute?
If NTD is Milo, it's going to take a couple minutes for the reset. The reason we need to do it is if right now we're okay as long as we don't have to make any switch changes, but if we lose a line or something happens, we lose a blocker, we won't be able to make any changes on the hand, on the fly to recover without doing this reset. We have to do it.
Okay, and CCSE, any input on this?
No, we don't have any concerns at this time. And STS.
Go ahead, STS.
What's the experience from Milo's side of having the datacom switch hang up and working this procedure to reconnect it?
We've seen this before, and the reset normally clears it all the time.
Okay, and NTD for you, knowing the CCSE won't see any impact, and it's a way to establish the comm configuration in case they got to go change something. You have my concurrence if you're okay with it, Jeff, to allow the Milo guys to reconnect and see if that's successful.
Yeah, based on what I'm hearing here, I'm go with that as well. Milo, go ahead and make that change and let us know when you get that.
Copy that, sir. Thank you.
NTS Row 212. Go ahead, Thoreau.
KC radar 19.39, partially operational. The skin track time has been reduced from 440 seconds to 290. We have removed radar 19.79 and the additional mandatory range passes go.
Excellent, thank you.
May I have your attention, please, for a brief announcement. The Space Shuttle Atlantis is planned for launch today from Pad A at Launch Complex 39. Although an accident during the first half minute of flight is unlikely, some safety precautions are necessary. A potential danger exists from toxic vapors contained in any cloud formed as a result of a launch mishap. In the event of an accident, all KSC personnel, news media, and invited guests on the Kennedy Space Center should take shelter in the nearest air-conditioned facility as quickly as possible. Those viewing the launch on NASA Causeway or at a launch viewing site not near an air-conditioned facility should take shelter in a bus or car with the windows closed. Please await further instructions which will follow. Repeating this announcement, the Space Shuttle Atlantis is planned for launch today from Pad A at Launch Complex 39. Although an accident during the first half minute of flight is unlikely, some safety precautions are necessary. A potential danger exists from toxic vapors contained in any cloud formed as a result of a launch mishap. In the event of an accident, All KSC personnel, news media, and invited guests on the Kennedy Space Center should take shelter in the nearest air-conditioned facility as quickly as possible. Those viewing the launch on NASA Causeway or at a launch viewing site near an air-conditioned facility should take shelter in a bus or car with the windows closed and await the further instructions which will follow. Thank you.
Copy that, Satoshi. We will check. Thanks.
NTDCFS. Go ahead. I can give you 1049. Copy 1049. And Houston flight, NTD ready for 1050. Perform BFS pre-flight uplink loading.
NTD Houston flight, I copy, and we will put the BFS pre-flight uplink load in work.
Go ahead. You may go ahead and put that in.
OTC PLT horizontal set config and config contingency abort gas here complete.
Copy that, and PLC, you've got to go for MTS helium reconfig for your checklist.
That's it, work.
NTD launch director 212. Yes, sir, go ahead. And how's your constraints look?
NTD Bala 212.
And launch director, we'll check on that and I'll get right back to you. Copy. Myla, NTD.
Yes, a data comm switch has been reset and we're nominal at this time.
All right, very good. And CCSU copy?
Yeah, CCSC copies and we saw no impact from that.
Excellent. And SPE copy as well?
SPE copies.
And Myla, you were good to go through launch in this configuration?
Yes, sir.
All right, very good. And launch director NTD?
Yes, sir.
We still have 4 open constraints that are all paper at this time that are being worked by our engineering folks in the back of the room to get those off the constraints list.
Okay, so no worries, right?
No worries.
Thank you.
OTC PLT MTS helium reconfig complete.
Copy that, thank you.
OTCP.
Ready, P.
Okay, kickoff for 1072.
You've got to go on 1072 FCP.
FCP copies. Copy and work. And NTDSP.
Go ahead.
Let's see, Jeff, just to let you know, I did just talk to CMQC. All 4 of the constraints that are currently shown on the constraint list are with CMQC for closure. They're doing a final review, and I expect them to come off the constraints list momentarily.
Great, thank you.
All personnel discontinue all non-mandatory LDV traffic for the remainder of the count.
NTD Houston flight on 212.
Correct flight.
BFS pre-flight uplink load is complete.
Copy, thank you. CVFS, you copy 1051?
BFS copies.
And for all personnel, we're going to hold at 9 in about 50 seconds or so.
NTDSP is with you, sir.
Go ahead.
Oh, I thought you were looking for me.
Okay.
This is Shuttle Launch Control, T-minus 9 minutes, 23 seconds and counting. We're preparing now to enter the final built-in hold on the countdown. This is approximately a 45-minute built-in hold.
Pete and the folks are working on it momentarily, and CMQC is aware it's on its way to them.
Going into the hold now in 4, 3, 2, 1. T-minus 9 minutes of holding for 41 minutes and 10 seconds.
Duration of our hold will be 41 minutes and 13 seconds based on our window open time.
Right now we're going to go out to Mission Control in Houston. Rob Navius is our flight commentator for STS 135, and we'll go now to Rob to tell us what the status is of Mission Control in Houston and the readiness for launch today.
Thanks, George, and good day, everyone. This is Mission Control Houston at T-minus 9 minutes and holding. Here in the Space Shuttle Flight Control Room, flight controllers belonging to the Ascent team have been on console since 4:30 this morning, monitoring Atlantis' systems in preparation for its final flight into space and the first step in the final mission in Space Shuttle program history. 30 years and 3 months ago, it was Columbia on Launch Pad 39A awaiting liftoff on the first shuttle mission. The Ascent team that day was led by Flight Director Neil Hutchinson, whose call sign was Silver Flight. He was assisted that day by a young astronaut named Dan Brandenstein, who served as the spacecraft communicator, or Capcom. Brandenstein would later fly in space 4 times, 3 times as a shuttle commander. Today, weather permitting, Atlantis will display its power and spectacle one last time under the direction of Flight Director Richard Jones, whose call sign is Sigma Flight. Jones will be assisted by Capcom Barry Wilmore, who will be talking directly to the crew during Atlantis' 8.5-minute ride to orbit. Wilmore is joined on console by astronaut Lee Archambault, who is monitoring weather conditions at the Kennedy Space Center. Archambault is in direct contact with Deputy Chief Astronaut Rick Sturckow, who is flying the shuttle training aircraft around the vicinity of the shuttle landing strip at the Cape. Sturckow is assessing the weather in the event Atlantis has to perform a return to launch site abort. Jones has already polled his team for a go for launch from a systems perspective, as has the International Space Station Flight Control team, led today by Flight Director Emily Nelson. At the time of Atlantis' launch, the International Space Station will be flying about 235 statute miles over the Pacific, east of Christchurch, New Zealand. Atlantis' launch is timed to match the moment when the Earth's rotation carries Launch Pad 39A into the corridor of the station's orbit. Shuttle flight controllers here in Houston are watching weather conditions at the overseas abort sites in Spain and France, which would be used in the event of an engine failure early in Atlantis' climb to orbit. Zaragoza, Spain is the prime transatlantic abort site today for Atlantis and its crew. The weather there is pristine. At launch, Atlantis will be sent aloft on the collective power of its 3 liquid fuel main engines and its twin solid rocket boosters, combining for a total of 7 million pounds of thrust. 30 seconds into the flight following its roll maneuver, the computers will throttle the main engines down to 72% of rated performance, designed to lessen aerodynamic forces on the shuttle's fuel tank and the orbiter's aero surfaces. The engines will throttle back up to 104% of capability 20 seconds later. Shortly after solid rocket booster separation, the orbital maneuvering system engines will ignite for 1 minute 23 seconds, providing an assist for the shuttle as it heads uphill. And a little less than 6 minutes into the flight, the onboard computers will command the main engines to swivel, allowing Atlantis to roll to a heads-up position above its fuel tank. That maneuver allows Atlantis to gain more favorable communications with the tracking and data relay satellite system. 8.5 minutes after launch, the main engines will be commanded to shut off, and the shuttle will separate from its fuel tank. Atlantis will settle into an elliptical orbit around 135 statute miles above the Earth at apogee, which will be refined to a higher elliptical orbit above the Earth about 37 minutes into the flight through a firing of the shuttle's orbital maneuvering system engines. Additional rendezvous maneuvers will be executed over the course of the next 2 days, bringing Atlantis to its final docking with the International Space Station on Sunday morning. Seconds after discarding the external fuel tank, Commander Chris Ferguson will execute a maneuver to place Atlantis in the correct orientation so that mission specialist Sandy Magnus can use digital cameras to capture high-resolution imagery of the tank as it drifts away. Because there are no crew members on the middeck for this launch, there will be no time for handheld video captured of the tank as it separates, only digital photos. Atlantis' 4 crew members will go to work shortly after the shuttle's payload bay doors are open, activating systems, unstowing gear, and preparing for their first 8-hour sleep period in orbit, which will begin around 7 p.m. Central Time. The sense of history, The legacy of what has occurred here over 3 decades is palpable here in the shuttle flight control room as Jones and the Ascent team stand by to take over control of the last journey of a space shuttle at solid rocket booster ignition. At T-minus 9 minutes in holding and with history in the offing, this is Mission Control Houston.
Houston flight NTD on 212.
NTD Houston flight on 212, go ahead.
Okay. Any updates to our launch window and or launch stream back hold times today?
No updates.
All right, very good. And let's see, OTC, TDC, PTC, LPS, MILA, SEM, Safety, SPE, LRD, SRO, CDR, and CGLS. We have our final launch window has been selected, and we are going with our preferred time, and that does move our launch window T0 time to 15:26:46 GMT, and that window will close at the same 15:31:19 GMT with a window length of 4 minutes and 33 seconds. Our lock stream back hold time is now 3 minutes and 16:16 seconds based on performance, and that will give us a T-minus 9 resume of 15:17:46.
TLS copies.
Thank you, GLS. And let's see, OTC copy?
OTC copy.
TDC? TDC copy. PTC?
PTC copies.
And LPS?
LPS copies.
MILA?
MILA copies.
STM?
STM copies.
Safety console?
Safe copies.
SPE?
SPE copies.
LRD?
LRD copies.
SRO?
SRO copies.
And CDR?
CDR copies.
Thank you all. And with that, CGLS, go ahead and set the countdown clock to resume at 15:17:46.
Yes, sir. 15:17:46. That's complete.
This is Shuttle Launch Control, T-minus 38 minutes, 43 seconds and counting.
Okay, very good, thanks.
Right now, our weather conditions here at the Cape are observed go, so we hope we can maintain that now for about another 45 minutes.
Can you give us our camera support for launch on 1097?
We're going to look now at
Cameras are ready to support, and
a video about the history of Space Shuttle Atlantis.
long range north,
It's
8. Long range south, 8.
Atlantis
Medium range north,
retro video
medium range south, 6.
about Atlantis' storied
west,
career.
6. And short range RSX. All right, very happy all.
Since first arriving at the Kennedy Space Center 25 years ago, Space Shuttle Atlantis has made the 4-mile trek from KSC's Vehicle Assembly Building to its oceanside launch pads more than 30 times. The fourth of NASA's 5 orbiters, Atlantis' career has not been lacking in firsts. Among them, the first shuttle to deploy a probe to another planet, the first shuttle to dock to a space station, and the first shuttle to fly with a glass cockpit. Atlantis has traveled more than 115 million miles in the pursuit of exploration. Its legacy enabled NASA and its international partners to accomplish some of the most complex work in human spaceflight history. Work that has yielded immeasurable benefits and allowed us to greatly advance the frontiers of knowledge.
Both of those are not required.
This is Shuttle Launch Control, T-minus 36 minutes, 15 seconds and counting. Once the external tank separates from Atlantis, 8 minutes and 30 seconds into the mission, it will be in an elliptical orbit of 136 statute miles by 36 statute miles. And then 45 minutes after launch, There will be a 2-minute burn of the orbital maneuvering system once again to raise and circularize the orbit to 141 statute miles by 98 statute miles. The orbit will then gradually be raised to 253 statute miles in order to rendezvous with the International Space Station. Should Atlantis need to turn around and come back, the primary abort once around location is the shuttle landing facility at the Kennedy Space Center, and there is an alternate backup site also available at White Sands in New Mexico. The primary end of mission site is here at the Kennedy Space Center at the shuttle landing facility, and the alternate is NASA's Dryden Flight Research Center at Edwards Air Force Base in California, as is customary. At T-minus 34 minutes, 50 seconds and counting, this is Shuttle Launch Control.
ATC CHD.
HGD.
I have some fill-in for step 935.
935, okay.
On page 1198. When you're ready.
Go ahead.
The op number is 80, run number is 1, and the log number is LCC4-062711-011.
Copy that, thank you.
And the medical diagnostic pack is empty, the spot for it. I was wondering if you knew where that was.
This is Shuttle Launch Control, T-minus 31 minutes, 57 seconds and counting. Shuttle Weather Officer Kathy Winters has just advised Shuttle Launch Director Mike Leinbach that we are still currently observed go for launch. We're watching an area that is inland that we believe will be passing to the northwest by about 3 miles at launch time, so assuming there are no buildups associated with it, and the shuttle training aircraft will be watching that closely. We are cautiously optimistic that we will be go for a launch at 11:26. Right now out at the launch pad, the temperature is 81 degrees and it's 83 at the shuttle landing facility. At T-minus 31 minutes, 10 seconds and counting, this is Shuttle Launch Control.
CCME, OTC.
CCME.
Steps 1077, 1078.
Complete.
Do you do 1078?
1078 was not performed.
Not performed, thank you. DDPS, OTC.
DPS.
Step 1085, 1086. Were those not performed?
That's affirmed.
Okay, and 1087 complete?
1087 complete.
Thank you.
SRO 212.
Go SRO.
Range is go for Canada resumption and 50 of 152646. Range status is go for launch.
Excellent, thank you.
CGLS, OTC.
Yes, ma'am, go ahead.
Step 1095, 1096.
Stand by, please.
This is Shuttle Launch Control, T-minus 28 minutes, 50 seconds and counting. A pre-flight software check of the Space Shuttle's master events controller called a bite check has been completed. This main engine controller relays commands from the orbiter's computers to fire explosive charges to the solid rocket booster hold-down bolts at launch and to separate the tanks and the twin boosters in flight. It's a customary milestone that occurs at about T-minus 29 minutes. Eastern Range has just given a go to pick up the countdown at T-minus 9, so the range is green. Launch weather appears to be good. We'll be watching the return to launch site weather very closely. The Spaceflight Meteorology Group in Houston will be making the call on our RTLS weather, and if we were go to pick up the count at T-minus 9. But we do have some sunshine here now, and we're going to be watching this area off to the northwest, but right now we're cautiously optimistic. And the post-launch inspection teams are being assembled right now at the roadblock located near the Launch Control Center.
OTC, CHD.
HDD.
I can give you step 1142. Our confidence tests are complete.
Copy 1142.
And that post-launch inspection team will be going into the pad as soon as it's determined that the pad is safe for crew entry. And the closeout crew has been cleared from the launch pad, as we've seen. The white room is configured for launch. At T-minus 26 minutes, 37 seconds and counting, this is Shuttle Launch Control.
DVD, OTC.
DVD.
Are we going to have to do step 1123?
That'll be not performed today.
Not performed, thank you.
OTC, CPBD.
Good, TBD.
Okay, I can also give you step 1126, payload bay purge flow rate set for launch.
Copy that, thank you.
And EDSP.
USP.
We got the CMTC here with us.
CMTC?
That's firm. CMTC here.
Okay, Jeff, one last lot of constraints listed is for our locked pump. The guys are struggling a little bit inside of IPRACA in order to get the dispositions and signatures in there. We are going to hand sign it back here, and then we will take it back to CMTC. And what I'd like to do is have CMTC remove that lot from the constraints list once it is delivered to him. Technically, we are okay to go fly, and then ought to be sufficient to get that last constraint removed from the constraints list.
Okay, CMTC, copy and concur?
Copy and concur.
Okay, and also SPE, if we, for some reason we can't get that this little hand done, we can still do it over the net here if we need to.
Understood. But we just hand signed it, so it's on its way back to CMTC.
Okay, excellent, excellent. All right.
Okay, and I appreciate that, and thanks CMTC for your support as well.
Not a problem, sir.
This is Shuttle Launch Control, T-minus 21 minutes, 24 seconds and counting, or correction, T-minus 9 minutes and holding with 21 minutes, 20 seconds remaining in this planned built-in hold. Continuing to count down toward picking up the countdown at T-minus 9 minutes. Right now we're looking at a little area of weather that's popped up over Merritt Island to the west. The larger area of precipitation to the northwest appears that it's going to be well biased by the time the launch is scheduled to go. However, the shuttle training aircraft with Rick Sturko is looking at that very closely to try to characterize exactly what it's doing and how stable it is and where it will be. as well as looking at this little small area that is over North Merritt Island that is gradually being characterized as something that could become a rain shower. And we want to see how safe that'll be. We have 18 minutes 20 seconds remaining in this built-in hold at T-minus 9 minutes. Rick Sturko reports that the weather looks reasonably stable to him. He doesn't see any buildups. We're looking at an area off to the southwest that looks good. However, the Spaceflight Meteorology Group in Houston that's in charge of forecasting weather for return to launch site has a number of factors that they have to consider. A combination of cloud ceiling, any buildups, any rain showers, all of this have to be factored into the flight rules. And then they will be the ones that will give us a go to proceed at T-minus 9 minutes. And if we need to, and it looked like the weather is going in the right direction, but we're not quite there yet, we could even count down all the way to T-minus 5 minutes and see what the weather holds for return to launch site. So it's looking our way. We're not quite there yet, but we're still cautiously optimistic. At T-minus 9 minutes and holding, 17 minutes remaining in this planned built-in hold. This is Shuttle Launch Control.
And attention all personnel, we have 16 minutes of hold time remaining here at T-minus 9 minutes. We're tracking no technical constraints. One paper item that we're looking to remove from our constraints list as we continue to watch our weather approaching our launch time.
Jesus. Station 2 on 2 for the physical exam.
Go ahead, Ron.
Yeah, Robert, we have been unsuccessful at opening the software to record the images of the tympanic membrane, and was wondering if you could walk us through the steps to do that. We're on SSC 8, and those procedures will not open.
Ron, were you able to open the data collection tool itself?
Yeah, we opened up the data collection tool and opened up the page on pre-EVA and entered the data there. It was page 1 of 1. It was just temperature and blood pressure and things like that. But then in somewhere in step 3, it tells us to photograph the tympanic membrane, and we've got everything hooked up to the USB drive.
TLC, OTC, clear hardware, caution warning memory, and verify no unexpected errors.
And we can't get.
TLC, that's in work.
Yeah, we can't get the HMS images.
We're checking.
On the data collection tool, if we where it says form selection, under the HMS choice, the only forms that will call up is the pre-EVA version.
OTC, TLP, clear caution. Hardware memory complete.
Copy that.
We're checking on it, Ron.
This is Shuttle Launch Control, T-minus 9 minutes and holding, 13 minutes 30 seconds remaining in this built-in hold. Joining us now is Pete Nikolenko. He is the Assistant Launch Director for today's countdown. And Mike, or rather Pete, I wonder if you could tell us, first of all, how does the vehicle look? And then tell us specifically what the weather is that we're looking at right now.
Sounds good, George, and good morning. The vehicle's really been performing exceptionally well. We've had a really clean countdown. A couple of very minor ground issues, but we've cleared those. And at this time, the crew's in, the teams are ready, and in the vehicle, the pad, and all the teams are ready to go. We have been watching the weather, and we knew that weather was going to present a challenge for us today. We are increasing our optimism. Certainly, things look pretty good on the launch weather side. Certainly, we're looking and working with the Spaceflight Meteorology Group and our Ascent flight director and the flight control team, because we want to ensure that the weather for our return to launch site abort landing, just in the event if needed, is good enough to support for launch. So currently we're watching some clouds and at a 12,000 foot level that are potentially building and moving into our general area, and so we need to protect this period of time, not just to protect for the launch window, but also for about 25 minutes after launch in order to provide appropriate visibility in case we had to return to this KSC launch site.
So does that mean that the weather reconnaissance aircraft, the STA with Rick Sturcos, is providing a lot of input to what he's actually seeing?
Absolutely. In fact, we're relying very heavily on the observed conditions of CJ in the shuttle training aircraft to see what, in fact, that they're really seeing up in the air and confirming what the meteorologists are working and seeing from their data. So combined together, we get the forecasters as well as the observations and conclude with the appropriate weather.
Well, Pete, thanks very much, and we'll let you go back to listening to those reports coming back from Rick Sturcos. We've got 11 minutes and 18 seconds remaining in this built-in hold at T-minus 9 minutes. This is Shuttle Launch Control.
And Station Houston, we are okay with just doing the manual check, and the manual scope should be in the medical document.
CMTC, OTC. Go ahead. Yeah, send somebody over to 145 standby with Ops 38 for the recorder activation, please. Somebody should be standing by, ma'am. Thank you.
This is Shuttle Launch Control. 10 minutes remaining in this planned built-in hold at T-minus 9. Before we come out of the hold, we're going to be listening very carefully to our launch director, Mike Leinbach, and our NASA test director, Jeff Spaulding, because they will be strategizing based on what is being observed, what we want to do as far as, first of all, picking up the count, whether we will or should not, and then if we do we want to press down all the way through, or might we take advantage of an optional hold at T-minus 5 minutes? So we should begin. I think they may hold off a couple of minutes on doing some of their polls before they get give that go. But at any rate, we're going to be monitoring that, and you'll be able to hear what Mike Leinbach and Jeff Spaulding have to say about what the strategy will be and what the directions to the launch team are. At T-minus 9 minutes and holding, this is Shuttle Launch Control.
CISL, JRPS, and Houston Flight. Performing L-15 recorder activation, ISL. ISL copies. JRPS. JRPS copies. And Houston Flight.
Houston Flight copies.
TLT, OTC. Panel R1, payload aux, switch on. And MS1, OTC. Activate the V10 recorder. Copy.
And attention all personnel, this is the entity conducting the launch status check. Verify ready to resume count and go for launch. OTC.
OTC is go.
TBC.
Tank and booster go.
TTC.
TTC's go.
LPS.
LPS is go.
Houston flight.
Houston flight, if you pull me at the end, I would appreciate it. Stand by.
Yes, sir, we'll pull you later. Mila.
Miles, go.
STM.
STM is go.
Safety console.
Safe console is go.
SPE.
SPE is go.
LRD.
LRD is go.
SRO.
SRO is go. You have a range clear to launch.
And CDR.
CDR is go.
And Launch Director NTD, our launch team is ready to proceed with the exception of Flight, who still needs a little bit more time to make his evaluations on RTLS weather.
I copy that. We'll do my poll at this time. KC Chief Processing Engineer, verify no constraints for launch.
No constraints.
Thank you, Steve. KC Safety and Mission Assurance.
Safety and Mission Assurance is go, Mike.
Thank you, sir. Payload Launch Manager.
Hey, Mike, on behalf of the ISS Ground Processing Team, I want to say thanks to you and the Shuttle team. It's been a great partnership, and we are go.
Thank you, Bill. Appreciate that. Range weather.
Launch weather has no constraints for launch.
Thank you, Kathy. Atlantis Flow Director.
On behalf of the and KSC Shuttle Processing Team, we are go.
Thank you, Angie. Ops Manager.
See, Mike, wait to get final go from flight here. Let's hear what he says, and we'll get back to you.
Copy that. Atlantis Launch Director, Air to Ground 1.
Atlantis go.
Okay, Fergie, we're starting to feel pretty good down here on the ground about this one today, so on behalf of the greatest team in the world, good luck to you and your crew on the final flight of this true American icon. And so for the final time, Fergie, Doug, Sandy, and Rex, good luck, Godspeed, and have a little fun up there.
Hey, thanks to you and your team, Mike, until the very end, you all made it look easy. The shuttle's always going to be a reflection of what a great nation can do when it dares to be bold and commits to follow through. Without ending the journey today, Mike, we're completing a chapter of a journey that will never end. You and the thousands of men and women who gave their hearts, souls, and their lives for the cause of exploration have rewritten history. Let's make this fall one more time, Mike, and witness this great nation at its best. The crew of Atlantis is ready for launch.
Thank you, sir. We'll get you going here in a couple of minutes.
NTD, Houston flight on 212.
Go ahead, Flight.
For the record, I'm go.
NTD copies, and Launch Director, that is our entire launch team, we are ready to proceed at this time.
I copy that. Ops Manager. Ops Manager.
Launch Director, Ops Manager on 212.
Yes, sir.
We discussed it with the MMT and the Flight Director. We were going to take a waiver to the RTLS forecast no-go based on the potential that there will be light precip if we ended up in an RTLS. They looked at that. Chances of thunder showers are very low, and they believe that's an acceptable risk. We have plenty of energy. We only need one end of the runway on the RTLS. I think we got some sound rationale here to take that waiver on the RTLS forecast being no-go. So with that, we are clear working wishes your good launch.
Okay, thank you, Mike. Appreciate that. And Fergie, you heard those words, so we'll get you going here shortly. Good luck, guys.
Fantastic news. Thanks, Mike.
NTD with that, you are clear to launch Atlantis.
I copy that, sir. Thank you. And for our entire test team, we have 1 minute and 15 seconds of hold time remaining here at T-minus 9 minutes before we will pick up the clock. And we do have a clear to pick up the clock at 9.
NTD ISL.
Go ISL.
Order activation complete.
Copy, thank you.
This is Shuttle Launch Control, T-minus 9 minutes in holding with 30 seconds remaining in this planned built-in hold. We'll pick up the countdown in 15 seconds. Picking up in 10 seconds.
The countdown clock will resume on my mark. 3, 2, 1, mark.
T-minus 9 minutes and counting.
TLS auto sequence has been initiated.
Ground launch sequencer will be checking over 1,000 parameters between now and when it hands off to Atlantis' onboard computers at T-minus 31 seconds. And from 31 seconds on, Atlantis' onboard computers will be completely in control of the countdown and for main engine start. And it will assess in the last 6.6 seconds whether the engines are up to full thrust.
TLT, OTC, connect essential buses to fuel cells per your checklist. Copy.
In about 20 seconds, we'll be retracting the crew orbiter access arm.
Yeah, this is go for orbiter access arm retract.
Atlantis, this OTC, this day has been over 30 years in the making. There have been many fabulous missions throughout the years. On behalf of KSC launch teams, past and present, we salute the entire astronaut corps for their dedication, not only for our expanded knowledge of the universe, but for the improvement you have contributed to on Earth. Have an excellent mission and Godspeed.
Fantastic words, Roberta. Thank you very much. Great to your team. Thank you, sir.
It's orbiter test conductor Roberta Wyrick from United Space Alliance. At T-minus 5 minutes, the pilot will be instructed to start the orbiter auxiliary power units.
JRPS OTC, start APU display recorders.
This JRPS recorders running.
TLT OTC, perform APU pre-start.
Pre-start, mark. OTC, TLT, 3-day contact.
Copy, 3-grade contact.
Coming up on T-minus 5 minutes in 3, 2, 1. T-minus 5 minutes and counting.
Yeah, let's go for orbiter APU start.
TLT OTC, perform APU start. CDR OTC, reconfigure heaters.
Solid rocket booster safe and arm devices are now being armed.
OTC, TLT, 3-day APUs.
Copy, 3 good APUs.
Next milestone is a check of the orbiter's flight controls.
TLS is code for purge sequence 4.
And there will be a steering check of Atlantis's 3 main engines. Verifying now that the main engines are in their start position.
TLS is code for ET LO2 pressurization.
Starting now the retraction of the gaseous oxygen vent arm, vent hood.
TLT OTC, clear caution warning memory, verify no unexpected errors.
Fuel cells going to internal. External tank camera being activated at this time.
OTC, TLT, no unexpected errors.
Copy that. Flight crew OTC, close and lock your visors and initiate O2 flow.
T-minus 2 minutes.
TLS is code for ET LH2 pressurization.
Solid rocket booster camera is being activated.
T-minus 1 minute, 30 seconds.
Sound suppression water system is being armed. T-minus 1 minute.
1 minute.
But oxygen and liquid hydrogen fill and drain valves are closed. T-minus 40 seconds, handing off to Atlantis' computers at T-minus 31. T-minus 35, 33.
Clock will hold at T-minus 31 seconds due to a failure.
And we have had a failure. Ground lock sequencer.
We had a problem on the retract switches. And ESC. Go ahead. So we need guys to go do the verification per the LCC, please.
All right, C-Mac.
It's C-Mac. The LTC says we need to verify using a camera, and we're positioning camera 62 right now.
Okay, let us know as soon as 62 is flown over and you can verify LCC for GDA retract, please.
And all personnel we're holding here 31 seconds while we get a verification that the GDA has fully retracted for our pre-climb.
This is C-Mac. We verify retracted.
Okay, and you can verify that it is fully retracted per the instructions that we're being followed, correct?
That's correct.
All right, and STE?
And STE concurs. They satisfy the requirements of GSE 13 pre-packet contingency on go.
Okay, I copy. And launch director.
Yes, sir. I heard all that. Concur.
Press on. All right, very good.
And STE.
Yes, sir.
Yes, sir. I need concurrence to GLS and ASK. Clear the hold, please.
Very good. And GLS, you have concurrence. Go.
Copy
got it. It's at work. Thank you. Let us know when that's complete. Nikki, we have any work?
All right, guidance.
Just a reminder for folks, our lockdown back hold time is 3 minutes and 16 seconds. NTDC, GLS on 212, we're ready to go. All right, very good. And launch director, with that cleanup, we're going to go ahead and proceed. Yes, sir, please do. All right, and all personnel, we are going to pick up the clock here momentarily. And GLS, you can resume the clock on your mark. Copy that. Countdown clock will resume on my mark. 3, 2, 1, mark.
T-minus.
GLS is go for auto sequence start.
Handoff to Atlantis' computers has occurred.
25 seconds.
Solid rocket booster nozzle steering check and work.
20.
Firing chain is armed.
15.
Go for main engine start. T-minus 10, 9, 8, 7, 6, 5. All three engines up and burning. 2, 1, 0, and liftoff. The final liftoff of Atlantis. On the shoulders of the space shuttle, America will continue the dream.
Roger, roll, Atlantis.
Houston now controlling the flight of Atlantis. The space shuttle spreads its wings one final time for the start of a sentimental journey into history. 24 seconds into the flight, roll program complete. Atlantis now heads down, wings level on the proper alignment for its 8.5-minute ride to orbit. 4.5 million pounds of hardware and humans taking aim on the International Space Station. 40 seconds into the flight, the 3 liquid fuel main engines throttling back to 72% of rated performance in the bucket, reducing stress on the shuttle as it goes transonic for the final time. Engines now revving up, standing by for the throttle up call.
Atlantis, go at throttle up, no action, DPDT.
Go at throttle up, no action on DPDT.
The call from Capcom Barry Wilmore and transducer, instrumentation only, no action required. Atlantis now 15 miles in altitude, already 16 miles downrange from the Kennedy Space Center, 1 minute 40 seconds into the flight. Atlantis flexing its muscles one final time. Atlantis traveling almost 2,600 miles an hour, 21 miles in altitude, 24 miles downrange, standing by for solid rocket booster separation. Booster officer confirms staging a good solid rocket booster separation. Guidance now converging. The main engine steering the shuttle on a pinpoint path to its preliminary orbit. 2 minutes, 20 seconds into the flight. Atlantis already traveling 3,200 miles an hour, 35 miles in altitude, 50 miles downrange. The propulsion officer reports the orbital maneuvering system engines have ignited. Atlantis kicking on its afterburners for 1 minute, 23 seconds for the final phase of powered flight.
Atlantis, 2-engine foul.
2-engine foul.
That call from
Atlantis
Capcom.
is a single pane day, so in the event of contingency, you're in plane plus 230 on the ecal page. No comm VIs when you're ready to copy.
Okay, in plane plus 230, go ahead.
Press the ATO, 10.8. Press the MECO, 14.7.
Press ATO, 10.8. Press the MECO, 14.7.
That's a good readback, Atlantis.
Because of the slightly late launch time, Capcom Barry Wilmore reading up to pilot Doug Hurley the updated abort boundaries for Atlantis. which is flying on the singular power of its 3 liquid fuel main engines, draining a half a ton of fuel per second from the shuttle's large fuel tank. 3.5 minutes into the flight, Atlantis traveling 4,200 miles an hour, 54 miles in altitude, already 120 miles downrange from the Kennedy Space Center. 3 good main engines, 3 good auxiliary power units, 3 good fuel cells for Atlantis.
Atlantis, negative return.
Negative return.
That call from Capcom Barry Wilmore indicating that we're too high in altitude, too far downrange to return to the launch site in the event of an engine failure. However, Atlantis' 3 engines performing perfectly. 4 minutes, 20 seconds into the flight. Atlantis currently traveling 5,500 miles an hour, 62 miles in altitude, almost 200 miles downrange. 4 minutes of powered flight remaining. Atlantis speeding straight as an arrow toward its date with the International Space Station Sunday morning. Coming up on the 5-minute mark. Atlantis now traveling 6,500 miles an hour, 66 miles in altitude, 250 miles downrange.
Atlantis, press to ATO.
Press ATO.
That call indicating we can make minimal orbital targets in the event of an engine failure. All 3 engines continue to function normally. Atlantis will begin its slow roll to a heads-up position shortly. Five and a half minutes into the flight, Atlantis traveling 7,700 miles an hour, 315 miles downrange.
Atlantis, single engine, ops 3.
Single engine, ops 3.
And the guidance officer here in Mission Control confirms that the computers are commanding the main engines to swivel.
Single engine, Zaragoza, 104.
Single engine, Zaragoza, 104.
We've rolled to a heads-up position now, providing better communications to the tracking and data relay satellite system as Atlantis heads uphill. 6 minutes, 20 seconds into the flight.
Atlantis, press to MECO.
That call indicates that we can make our normal orbital cutoff targets in the event of an engine failure. However, all 3 main engines continue to function normally.
Is nominal. Fergie, go to the plus X, go to the pitch.
Nominal shutdown plan, go for the plus X, go for the pitch.
That call indicating that we will be in good shape for the orientation of Atlantis for external tank photography following main engine cutoff. Now 7 minutes into the flight. One minute, 20 seconds till main engine cutoff. Atlantis traveling 12,000 miles an hour. The main engines will soon be throttling down once again to limit the stress on the shuttle and its 4 crew members to that of 3 times the effective gravity. Atlantis currently traveling at a speed of more than 4 miles a second. 1 minute of powered flight remaining for Atlantis. Three good main engines, 3 good auxiliary power units, 3 good fuel cells. Approaching the 8-minute mark into the flight. Atlantis now traveling more than 15,000 miles an hour. Eight minutes, 15 seconds into the flight, standing by for main engine cutoff. That'll be followed a few seconds later by the separation of the external fuel tank. Booster officer confirms main engine cutoff. For the last time, the Space Shuttle's main engines have fallen silent as the shuttle slips into the final chapter of a storied 30-year adventure. Now standing by for external tank separation. Atlantis off the tank. Commander Chris Ferguson will be maneuvering Atlantis now into an orientation to enable Sandy Magnus to capture digital still imagery of the external fuel tank as it drifts away.
OHMS 1 is not required. Your preliminary OHMS 2 TIG, 37 minutes.
37 minutes, no OHMS 1 required, thanks.
Congratulations, everybody. And to start the speeches today, our Center Director, Bob Cabana.
Thanks, Mike. I just, words can't express.
This is Mission Control Houston. Atlantis safely in its preliminary orbit.
The gratitude that I have for
following a flawless launch from the Kennedy Space Center, albeit about 2.5 minutes late at 10:29 a.m. Central Time.
Team of technicians and engineers.
The launch slightly delayed while engineers at the Kennedy Space Center confirmed the complete retraction of the gaseous vent arm at the launch pad.
Thank you for your service to our country. Thank you for your service to NASA and the Kennedy Space Center.
Commander Chris Ferguson is currently orienting Atlantis into the proper
outstanding ride that we have
attitude to enable Sandy Magnus to capture digital still imagery of the external fuel tank as it drifts away for the final time. Atlantis currently in an orbit of 140 by 36 statute miles. That's the preliminary orbit that will be increased in altitude at its apogee through the firing of the orbital maneuvering system engines 26 minutes from now.
You need to have an appreciation for what you did. It was absolutely incredible. Brian O'Connor and I were back talking. Some of you who have been around long enough to remember, we had a similar thing happen on STS-1 when we stopped at 31 seconds, and I think it was for a BFS computer or something, and you all performed flawlessly then to get us off, and again, you did it today. It has been my honor and pleasure to be with you as a member of the team. Thank all of you. And the thing I would tell you is, take a deep breath, enjoy a little time here with your families again, but we've got a lot of work to do. We've got another program that we've got to get underway. Savor this one over the next couple of weeks, but I need for all of us to start turning to, because we've got work to do, because we've got other places that we really want to go. And we know what we're doing. We know how to get there. We've just got to convince everybody else that we know what we're doing.
Atlantis,
So,
ready for
God bless all of you.
STS,
Thank you for everything.
That's affirmative, Chunky. We are ready.
Okay, folks, let's see, our last launch together. Launch Director Award this time goes to you guys, the Prime Launch Team. And the
Chunky,
support launch
also,
team, and
after
all
you get
other
those closed, we'll be
supporting
ready for
elements around
APU
the
high
Space Center.
shutdown. On 3-4, the only delta is telling control is not required. And when you get ready for Ops 105, we are ready as well.
Here, Pete, you want to open this one? It's the little one. It's the little envelope.
on 3-4, except tail only control not required, and you're ready for 105.
That's a good readback.
So that's for you all. A little something to remember today's launch by. Maybe you carry it with you wherever you go in the future. And it's a reminder you've been a member of the Space Shuttle launch team, the greatest launch team in the world. So that's from me to you. Please take it with you, enjoy it. I'd like to recognize 10 or 11 very special people before we break up today. These are folks that have been on this team since STS-1, and they're here with us today. Kip Anderson, Debbie Autonomo, Bernie Bailey, Ken Four, Daryl Geen, E.W. Hall, Bob Hulse, Mike Palmer, John Sterrett, Greg Weber, and Roberta Wyrick. For those folks, that was just very special, and I'm proud of you. I love you all.
This is Mission Control Houston here in the Shuttle Flight Control Room.
One last comment. From the beginning of the
Post-insertion activities underway under the direction of Ascent Flight Director Richard Jones, second from your right, who presided over all of the work that was done associated with making sure that the weather was acceptable for launch from a return to launch site abort standpoint for the Spaceflight Meteorology Group. On the far right, Flight Director Tony Sacacci, he will preside over Atlantis' final entry 12 days from now. Butch Wilmore, Barry Wilmore, the Capcom, the spacecraft communicator, in the dark shirt, and on the far left, Lee Archambault, the astronaut who was in direct contact with Deputy Chief Astronaut Rick Sturko. Sturko was assessing the weather and real-time observations as he flew the shuttle training aircraft around the vicinity of the Kennedy Space Center in the final hours prior to launch.
One last thing, don't anybody leave yet. We got some photographers coming in. We're going to get pictures of the whole team, please. So
handshakes all around here in the Shuttle Flight Control Room. As we move into the post-insertion time frame, the initial phase of getting Atlantis set up for orbital operations, the countdown clocks here in Mission Control currently ticking backward to the first firing of the orbital maneuvering system engines in what is known as the OHMS tube burn, just a bit under 22 minutes from now. That will begin to raise the orbit, the apogee of Atlantis' orbit. Essentially, the launch itself was the first rendezvous maneuver to catch up to the International Space Station for a docking on Sunday morning. With Atlantis in the early minutes of its final flight, and the final flight in the history of the shuttle program, we're going to go back down now to the Kennedy Space Center at the launch site for replays of today's launch that occurred at 10:29 a.m. Central Time.
TIG of 37:45, we like that, and no deltas to 3-6 or 3-7.
Okay, we copy. No deltas to 3-6 or 3-7. We'll put 3-5 and subsequent in work.
Thanks, Atlantis. We're watching.
tag up with you. We show ourselves complete through the MPS power down, just waiting on your go when the time comes.
Okay, we are ready for MPS power down when on time, and if you could check the MPS pneumatic helium ISO to GPC, that should get them.
Okay, pneumatic helium ISO to GPC. Thanks for the check.
As we watch the replays of Atlantis' final launch, Capcom Barry Wilmore talking to Commander Chris Ferguson on board Atlantis. The main propulsion system has been shut down. The external tank umbilical doors have closed. The auxiliary power units have been shut down. Everything going well. Less than 22 minutes following Atlantis' launch. The crew on board Atlantis will be busy over the course of the next several hours setting up shop on board the orbiter, activating payload buses, breaking out laptop computers, preparing for the opening of the payload bay doors, after which the Ascent team of flight controllers will assess all of Atlantis' systems for a go for on-orbit operations. A slightly longer workday than usual for the crew of Atlantis, since there are only 4 crew members on board instead of the usual 6 or 7. Later in the day, the checkout of the shuttle's robotic arm, along with other activities preparatory to the inspection that will take place of Atlantis' thermal protection system tomorrow, standard customary operations for the second day of any shuttle flight.
Houston, Atlantis, MPS power down is complete, and with that, we would like to thank the Pratt & Whitney Rocketdyne team and the SSME team for their flawless performance over this 30-year shuttle flight history. 135 flights, It's a 7,000-pound engine that puts out 1.5 million pounds of thrust, and they pitch the equivalent of a perfect game every flight. From everyone who's ridden on these rockets, we thank you.
We concur with that assessment, Atlantis. Good and pertinent and true words.
We're putting ET umbilical door closure in work, Butch.
Mechanical Systems Officer here in Mission Control watching over the closing of the external tank umbilical doors. Words of compliment from pilot Doug Hurley for all of the propulsion system engineers who presided over 135 flights of the Space Shuttle, and the performance of Space Shuttle main engines, the external fuel tank, the solid rocket boosters that propelled these vehicles, and hundreds of humans to orbit. The external tank umbilical doors now closed and latched, confirmed by the Mechanical Systems Officer here in Mission Control. Atlantis soon to maneuver into the correct orientation for the firing of the orbital maneuvering system engines about 9 minutes from now, the OHMS 2 burn that will help to refine Atlantis's altitude as it now begins its trek to catch up to and dock with the International Space Station on Sunday.
Hey, Houston, we're ready for the maneuver if you are.
Affirmative, Atlantis, we are ready.
Atlantis now beginning to maneuver into the correct orientation for the firing of the orbital maneuvering system engines 7.5 minutes from now. This will be a firing of both orbital maneuvering system engines at the rear of the shuttle that flank the vertical tail fin. The firing of this OHMS 2 burn, as it is called, about 1 minute 4 seconds in duration. This is Mission Control Houston, less than 2 minutes away from the orbital maneuvering system burn to increase Atlantis' altitude. This will be a 1 minute 4 second firing of both orbital maneuvering system engines. The guidance, navigation, and control officer reports Atlantis is in a good configuration for the burn, as does the propulsion officer here in Mission Control.
Hey, Houston, we think we're in a good config for the burn.
That's affirmative, Atlantis. We show you in a good config for the OHMS 2 burn.
Standing by for the firing of the orbital maneuvering system engines. And the propulsion officer reports that the OHMS 2 burn is underway.
We see a good burn, Atlantis. No further trim is required. We'll meet you in the post-OHMS 2 tab.
Copy and concur. Thanks, Houston.
And as we watch the replay of Atlantis separating from its external fuel tank following its launch almost 40 minutes ago, the confirmation from Capcom Barry Wilmore here in Mission Control to Commander Chris Ferguson that we've had a good firing of the orbital maneuvering system engines, the OHMS 2 burn helping to refine Atlantis' altitude as it begins its trek on the road for its 2-day chase to catch up to the International Space Station. Atlantis now at an altitude of 143 by 98 statute miles.
Here comes the gimbal check, Houston.
We are watching. And Chunky, no deltas to your post-burn reconfig.
Copy, no delta.
Great view on Elstow, Atlantis.
I love it when a plane comes together.
Amen.
The door's in the process of swinging open. The starboard door, as you can see, is already open. The port door to follow. You're looking right down at the front end of the Raffaello multipurpose logistics module, carrying some 8,000 pounds of logistics supplies to fortify the International Space Station for the next year. On the far right, nestled against the payload bay door, is the shuttle's robotic arm that will be unfurled and tested within the next few hours by Commander Chris Ferguson and pilot Doug Hurley in advance of its grappling of the orbiter boom sensor system for the initial inspection of the shuttle's thermal protection system tomorrow. Now the port door begins to swing open. In this split screen image on the left is the shuttle's KU band communications antenna, which also will be deployed a short time from now. And the mechanical systems officer reports the payload bay doors have been opened for the final time on Atlantis. Here in the flight control room, Flight Director Richard Jones now polling his team to get a go for on-orbit operations.
Atlantis, we just polled the room, and you are go for orbit ops.
Go for orbit ops. Great news, Houston. Thanks.
So with that, the crew will begin the process of doffing their launch and entry suits, and we'll press ahead now for the deployment of the KU band communications antenna and the setup of the laptop computers on board the orbiter. Also on tap, the activation of the star trackers, the stowage of the escape pole, and other items that will clear the path for the rest of the day's activities that will culminate in the crew going to sleep around 7 p.m. Central Time tonight.
Flighty-com.
How are we doing on cabin leak checks?
They're pressurized the cabin, about to pull the probe here. Looks like they're doing it now, so we're working our way through it.
Copy.
Flight GC.
Go.
We had good death source checks. We can give them a sequence 912.
912, thank you.
Yes.
Cabin pressure integrity checks. We've got a good check, and we're going to be starting to vent it in about 5 minutes.
Copy that, thank you.
Got to go for water spray boiler GN2 supply activation per your checklist.
That's verified.
Okay, thank you.
CDR on clear. VIP.
MS1, MS2.
Atlantis Houston, we read you all loud and clear, and we are ready now for updates. The first one is your altimeter setting on page 1-10, and that setting is 29.96.
Okay, Butch, we have P996.
That's a good read back, Atlantis. The next update is on flipbook page 2-4.
All right, ready to copy.
All right, your no-com mode boundaries updates are pressed to ATO 104 or 10.5. Your single engine ops 3 109, we're going to leave at 12.3. Press to MECO 104, 14.4. Single engine press 104 will be 17.4.
OTC, Pete.
Go ahead.
I can use steps 931 through 934. Mech pre-flight evaluation complete. No mech failures.
Copy that. Thank you.
We're getting close, folks. What I want to do is I want to get the go-no-go from a systems perspective early, and I'll get that done, and then that will allow us to just focus on the weather as we walk in closer. So expect a go-no-go in the next 10 or 15 minutes.
I'd like to say that it's been an honor. Thank you for everything. For representing this fine, magnificent team that is KSC, we thank you. And as I leave this flight room today, turn over my flight crew to you. I ask that you please return them to the good Mother Earth. Godspeed to all. OVCC off the net.
Thank you, my friend. You've done a great job for all these years.
You're with us in spirit, Travis.
Okay. Any updates to our launch window and or lock stream back hold times today?
No updates, flight. No updates.
All right. Very good. And let's see. OTC, TBC, PTC, LPS, MILA, STM, Safety, SPE, LRD, SRO, CDR, and CGLS. We have our final launch window has been selected, and we are going with our preferred time, and that does move our launch window T0 time to 15:26:46 GMT, and that window will close at the same 15:31:19 GMT with a window length of 4 minutes and 33 seconds.
The constraints listed is for our LOX pump. The guys are struggling a little bit.
The potential that there would be light precip if we ended up in an RTLS, they've looked at that. Chances of thunder showers are very low, and I believe that's an acceptable risk. We have plenty of energy. We only need one end of the runway on the RTLS. I think we got some sound rationale here to take that waiver on the RTLS.
Flight and FIDO if it's enabled.
So with that, we are clear, no working, no issues. Your go to launch. Okay, thank you, Mike. Appreciate that. And Fergie, you heard those words, so we'll get you going here shortly. Good luck, guys. Mark, T-minus 9 minutes and counting.
TLS auto sequence has been initiated.
Improvements you have contributed to on Earth. Have an excellent mission and Godspeed.
Fantastic words, Roberta. Thank you very much. Great to your team. Thank you, sir.
Okay, CONUS weather, let's keep going. What region of the atmosphere would you say that we need to focus that is going to be on top of the SLF roughly at RTLS time? So we're talking roughly an hour from now. And if you can use your cursor, that will help.
Okay, stand by. Let me get the video switched.
TLT, OTC, perform APU start. CDR, OTC, reconfigure heaters.
That's in work. That's in work.
TLS is go for ET LH2 pressurization.
Flight booster, 3 engines ready.
Copy, 3 ready.
Clock will hold at T-minus 31 seconds due to a failure.
FIDO flight, we're holding at 31.
We have a problem on the GOGS retract switches.
The run-on set is holding.
And NTDSP.
Go ahead.
Yes, sir, we need guys to go do the...
We're clearing SPC flight. Okay, GC, go ahead and make sure that we have a good clock coming.
Working on a flight.
SCMAC. All right, and SPE?
And NTD, SPE concurs. They satisfy the requirements of GSC-13 pre-plan contingency. I am go.
Okay, I copy. And launch director? Yes, sir. I heard all that and concur. Press on.
On my mark. 3, 2, 1, mark. TLS says go for auto sequence start.
Redundant set is counting.
Copy.
25 seconds. 20. 15.
All vents open.
10 seconds.
Copy
TLS
vents.
says go for main engine start.
Liftoff confirmed.
Copy liftoff.
Roger, roll, Atlantis.
Guidance sees a roll. Good roll maneuver.
Copy, good roll.
On PDO.
Atlantis, go at throttle up, no action, DPDT.
Go with throttle up, no action on DPDT.
Yeah, Atlantis, we think it's cabin stretch.
Ecom Fess.
Good Fess.
Negative return.
Atlantis, negative return.
Prop, everything was good with OHMS assist shutdown.
Single engine off 3. Single engine Zaragoza 104.
Atlantis, single engine Zaragoza 104.
Mako confirmed.
Copy, Miko.
Flight 5 of nominal Miko, OHMS 1 not required.
Copy, nominal Miko. How about OHMS 2 TIG, Fido? I'll take a preliminary.
37 minutes flight.
Thanks.
ET SEP.
Copy. Folks, we're going to be in the post-OHMS 1 pages.
Flight GNC, the pitch is complete.
Copy that.
And you have replaced the white crew?
131 is, you know. They'll end up patching that over to command net.
And SCO LRD 135.
We're green on launch, but now RTLS mode on flight.
Almost.
What you are just amazing. Just amazing to me. It's just
How lucky are you?
yeah, exactly.
West Virginia and Virginia coming together.
Yep.
Shuttle launch team.
The red ants was everywhere. When we went back, Jackie said, I don't care where we stop, it's going to be on.
We're using camera 4 or camera 62. This guy here is 416.
You can put that picture on your LinkedIn profile. She shows that picture.
It's moved into the northeast so well that it's going to be well offshore.
25 was real close. What? 25.
That night? So an hour window. I mean, 20-minute hold. Wasn't it? You had a meeting.
So, it's
Get you just a second. Hold on.
Everything else is kind of doing a couple little paper cleanups, but we're good over here. Everything's buttoned up, everybody's cleared back, and we're just participating in the weather discussion. And we're good on the launch side, so we're just listening to the SMG, I guess, trying to get their forecast. Yeah, so we're listening to CJ, and he's Captain, that little area of concern is that's what I wanted. No, I just wanted to get your updated launch weather forecast. So you're green. Copy.
Let me know if I got a problem.
Here, flight override. So you know. It's all about
this unless you think there's a safety issue. And I don't think it's all about risk management. That's all we're talking about. And you understand?
Yeah, they're expecting
They're ready.
to go.
Let's be ready.
They're ready to go.
Okay, guys, let's get ready.
We're getting there.
Bob, let's get ready. We're gonna go. Go.
All the way down to 10.
Copy that. Atlantis launch director, air to ground 1. Okay, Fergie, we're starting to feel pretty good down here on the ground about this one today. So on behalf of the greatest team in the world, good luck to you and your crew on the final flight of this true American icon. And so for the final time, Fergie, Doug, Sandy, and Rex, good luck, Godspeed, and have a little fun up there.
Their dedication, not only for our expanded knowledge of the universe, but the work that you have contributed to on Earth. Have an excellent mission and Godspeed.
Good job, Bert. Almost teared up. Almost. This is hard. Stay to launch the shuttle. Cool. Engine.
No birds, Mike.
Thank you.
Back, we're good.
Howdy.
Oh, it's
One more time.
Yes, sir. Please do.
All three engines up and burning. 2, 1.
Look at the shadow. Set. Friday for set.
It's an AST.
Let's go launch director. Let's go launch director 2-3. 2-3-2. What is Friars doing? Purple. Purple.
One last time to shine, man. You couldn't have done it better. I was real proud of you, Mike.
One more time.
Terrific, man.
I just, words can't express the pride that I have in all of you and the gratitude that I have for the job that you do. This is the most outstanding group of professionals, the most dedicated launch team of technicians and engineers anywhere in the world. And the United States owes you a deep debt of thanks. And I want to thank you for your service to our country. Thank you for your service to NASA and the Kennedy Space Center, to the Shuttle program, and most of all, thank you for this outstanding ride that we have had for the last 30 years aboard a United States Space Shuttle. You guys are absolutely the best. Thank you.
Here, you know, you all are incredible when you're pressed. I sat back in amazement and watched you perform when we stopped at T-minus 31. You need to have an appreciation for what you did. It was absolutely incredible. Brian O'Connor and I were back talking. Some of you who have been around long enough to remember, we had a similar thing happen on STS-1 when we stopped at 31 seconds, and I think it was for a BFS computer or something, and you all performed flawlessly then to get us off. And again, you did it today. It has been my honor and pleasure to be with you as a member of the team. Thank all of you. And the thing I would tell you is, you know, take a deep breath, enjoy a little time here with your families again, but we've got a lot of work to do.
Okay, folks, let's see, our last launch together. Launch Director Award this time goes to you guys, the Prime Launch Team, and the Support Launch Team, and all other supporting elements around the Space Center. There's a little something on your console if you open those envelopes, please.
Not the big one.
One last comment. From the beginning of the manned spaceflight programs, the launch director has had the honor of bidding the astronauts farewell on their missions. And it's tradition to say Godspeed, and the definition of Godspeed I like it best is have a prosperous journey. And folks, from the bottom of my heart, good luck and Godspeed. Thank you all very much.
Wave your flags. Oh no. Very cool.
You gotta get the group photo. The group photo. The whole
T-minus.
Go for auto sequence start.
Handoff to Atlantis' computers has occurred. Solid rocket booster nozzle steering check and work.
20.
Firing chain is armed.
15.
Go for main engine start. T-minus 10, 9, 8, 7, 6, 5. All three engines up and burning. 2, 1, 0, and liftoff. The final liftoff of Atlantis on the shoulders of the space shuttle. America will continue the dream.
Program, Houston.
Roger, roll, Atlantis.
Houston now controlling the flight of Atlantis. The space shuttle spreads its wings one final time for the start of a sentimental journey into history. 24 seconds into the flight, roll program complete. Atlantis now heads down, wings level on the proper alignment for its 8.5-minute ride to orbit. 4.5 million pounds of hardware and humans taking aim on the International Space Station. 40 seconds into the flight, the three liquid fuel main engines throttling back to 72% of rated performance in the bucket, reducing stress on the shuttle as it goes transonic for the final time. Engines now revving up, standing by for the throttle up call.
Atlantis, go at throttle up, no action, DPDT.
Go with throttle up, no action on DPDT.
That call from Capcom Barry Wilmore, a transducer, instrumentation only, no action required. Atlantis now 15 miles in altitude, already 16 miles downrange from the Kennedy Space Center, 1 minute 40 seconds into the flight. Atlantis flexing its muscles one final time. Atlantis traveling almost 2,600 miles an hour, 21 miles in altitude, 24 miles downrange, standing by for solid rocket booster separation. Booster officer confirms staging a good solid rocket booster separation. Guidance now converging. The main engine steering the shuttle on a pinpoint path to its preliminary orbit. 2 minutes, 20 seconds into the flight. Atlantis already traveling 3,200 miles an hour, 35 miles in altitude, 50 miles downrange. The propulsion officer reports the orbital maneuvering system engines have ignited. Atlantis kicking on its afterburners for 1 minute, 23 seconds for the final phase of powered flight.
Atlantis, 2-engine towel.
However, Atlantis' 3 engines performing perfectly. 4 minutes, 20 seconds into the flight. Atlantis currently traveling 5,500 miles an hour, 62 miles in altitude, almost 200 miles downrange. 4 minutes of powered flight remaining. Atlantis speeding straight as an arrow toward its date with the International Space Station Sunday morning. Coming up on the 5-minute mark. Atlantis now traveling 6,500 miles an hour, 66 miles in altitude, 250 miles downrange.
Atlantis, press to ATO.
Press to ATO.
That call indicating we can make minimal orbital targets in the event of an engine failure. All 3 engines continue to function normally. Atlantis will begin its slow roll to a heads-up position shortly. Five and a half minutes into the flight. Atlantis traveling 7,700 miles an hour, 315 miles downrange.
Atlantis, single engine, ops 3.
Single engine, ops 3.
And the guidance officer here in Mission Control confirms that the computers are commanding the main engines to swivel.
Zaragoza, 104.
Single engine, Zaragoza, 104.
We've rolled to a heads-up position now, providing better communications to the tracking and data relay satellite system as Atlantis heads uphill. 6 minutes, 20 seconds into the flight.
Atlantis, press to MECO.
Press to MECO.
That call indicates that we can make our normal orbital cutoff targets in the event of an engine failure. However, all 3 main engines continue to function normally.
Nominal. Fergie, go the plus X, go the pitch.
Nominal shutdown plan, go for the plus X, go for the pitch.
That call indicating that we will be in good shape for the orientation of Atlantis for external tank photography following main engine cutoff. Now 7 minutes into the flight. One minute, 20 seconds till main engine cutoff. Atlantis traveling 12,000 miles an hour. The main engines will soon be throttling down once again to limit the stress on the shuttle and its 4 crew members to that of 3 times the effective gravity. Atlantis currently traveling at a speed of more than 4 miles a second. 1 minute of powered flight remaining for Atlantis. Three good main engines, 3 good auxiliary power units, 3 good fuel cells. Approaching the 8-minute mark into the flight. Atlantis now traveling more than 15,000 miles an hour. Eight minutes, 15 seconds into the flight, standing by for main engine cutoff. That'll be followed a few seconds later by the separation of the external fuel tank. Booster officer confirms main engine cutoff. For the last time, the Space Shuttle's main engines have fallen silent as the shuttle slips into the final chapter of a storied 30-year adventure. Now standing by for external tank separation. Atlantis off the tank. Commander Chris Ferguson will be maneuvering Atlantis now into an orientation to enable Sandy Magnus to capture digital still imagery of the external fuel tank as it drifts away.
OHMS 1 is not required. Your preliminary OHMS 2 TIG, 37 minutes.
37 minutes, no OHMS 1 required, thanks.
From Launch Complex 39 at the Kennedy Space Center in Florida, this is Shuttle Launch Control at T-minus 3 hours and holding. We have approximately 1 hour and 45 seconds remaining in this planned built-in hold, and we're now in the final 5 hours of the countdown for the launch of the last flight of the Space Shuttle program and Space Shuttle Atlantis on STS-135. The countdown is being controlled from Fire Room 4 at the Launch Control Center, and we're on schedule for a liftoff targeted for 11:26 a.m. This is the 135th launch of the Space Shuttle program, the 33rd launch of Space Shuttle Atlantis, its 12th to the International Space Station, and overall the 37th flight to the International Space Station by the Space Shuttle. This is currently planned as a 12-day mission that would have the landing at Kennedy Space